Hello team, welcome back. And this is a new section we have started about the Docker images. This is the first lecture of this particular section, and here we will learn about the Docker images introduction. So let's start with. So in this particular section, we are going to learn a complete concept of the Docker images, which will cover the building of Docker images, the deployment of Docker images in the Docker. Then we will see the images management, like how you can create your images, how you can build your images, how you can tag your images, and how you can keep your images, and how you can upload your images over the internet. We will also learn about the Docker Hub central repository. So Docker have a central repository where we can upload our images. We will see the management of local images and how we can build the local images. So these are the things we are going to learn and discuss in this particular section. Let's start with the very basic, what is Docker image. So in a very simple and layman term, we can define in Docker everything is based on the images. And an image is a combination of file system and the parameters. So basically when we are talking about an image, we are talking about the file system and the parameters that image will accept when you will execute that particular image. So suppose you are working on an application and you want to create the Docker image of that particular application. So your image will contain the binaries which you are using inside your application, and it will also accept and it will also include the dependency of your application. After then it will accept some runtime after that it will accept some runtime parameters so that you can execute your image. Images contains the data required to run the images, right? So we have already discussed about it. When we are creating the image, so we need to wrap the binary files, we need to wrap the dependencies, and we need to wrap the metadata or the data which is required to execute that particular image. Suppose you want to list all the Docker images available on your machine. For this you can use the Docker command Docker images. There is another important point about the images. Images don't contain the operating system and operating system packages, right? It is the responsibility of the Docker engine to execute your image, right? Docker engine will basically deploy over some kind of operating system, so it will share the kernel of that operating system and execute your image. Any Docker image will not contain the complete OS and OS package to execute your application inside the Docker. Now we will discuss about this particular command we have seen to list out the Docker images. For this, I need to go to my console, and this is the machine where I am executing my Docker engine. I will execute a command docker ps. See, nothing is running right now. So to verify the images which is present on my machine, I will execute a command docker images. Hit enter button, and you can see all the images are being listed over here. So we can see we are getting the repository name, we are getting the tags, we are getting the image ID, the created date, and the size. So this is the repository name. Repository name basically is the image name, right? And tag is basically tag is associated with the image which will define the version of your image. So this is nginx alpine image, right? The image ID is AAE467EE77D. So what is this image ID? This is a random generated image ID which will be generated when you download any image. Over here we are also getting the time that image is basically downloaded 3 weeks ago and size is 17.7 MB, right? Now we have another image of nginx which is nginx latest version, which have the different image ID which also created 3 weeks ago, but the size is different. You can see the nginx, the both images are basically the nginx, but the alpine one have 17.7 MB and nginx latest image have 109 megabyte in size. So here there is a huge difference in the size of nginx alpine and nginx latest. So nginx alpine is a image which is specific to alpine linux, right? Nginx latest image is basically applicable with all kind of operating system of which is unix based or linux based. So here we are getting an ample enough data to identify the image. We are getting the image name, we are getting the tag, ID and the time when the image was basically downloaded and the size as well. So this is the way how you can list out all the images which is present on your machine. So thank you team. Thanks for your time. Hello team, welcome back. And today we will discuss about Docker Hub repositories. So we will see where Docker kept all the official images and where we can post, upload our local images on Docker. So we are going to learn about the Docker Hub. Then we will see and take a tour of Docker Hub official site. We will find out some official images which is being provided by the Docker community. We will download the images. We learn about the images tag and their application. So let's start with. So Docker images can be downloaded from the Docker Hub. So in the last lecture we have seen we have a few images on a machine when we which we will download it when we was executing Docker run command. So basically these images was basically downloaded from the Docker Hub. Image is something which can be committed with changes and have multiple versions. So if you don't have a specific version number, then the client defaults to the latest. So we have seen the tag was latest in some kind, the tag was alpine in some other way, the tag was some different. So basically we can also push the image on the Docker Hub, and if we are not defining a specific version to our image, then by default Docker takes the default as a latest. Now, first we will discuss about the Docker images differentiation. So very first, we'll talk about the base image. So base image is the type of image that have no parent image. So usually the images like the operating system, Ubuntu, BusyBox, Debian, these are the base images. And base images is basically a big image in a size, right? Now, second version of image is called the child image. So child image is something which is built on base image and providing some additional functionality, right? So suppose you have Ubuntu base image, then you have another image which is basically using the Ubuntu images, but they are providing their own functionality. They are providing some interactive CLI, they are providing some interactive colors, right? So these are called the child images. The third type and important type of the images is official image. So images that are officially maintained and supported by the Docker community are called the official images. These are typically one word images. The next category comes user images. So these are the images which is basically belongs to the user like you and me, the images which belongs to some specific organization. So these images are being created and shared by the users, and they build on base image and additional functionality. Typically these are formatted as user slash image name. So we will see the different images. We will see the image name, how the official image display inside the Docker Hub, and how the user's image display inside the Docker Hub. Now let's take a tour of dockerhub.com. So you need to go to Google. In a Google, type Docker Hub, hit enter. So you will get a very first site which is the official Docker Hub site, which is https hub.docker.com. I will open this site. So this is the default page. When you will open the first time the Docker Hub, you will land on this particular web page. If you don't have the Docker Hub account, then you need to create your account. If you have your account, then you need to go to sign in and sign in on your account. So I already have an account, so I will sign in my Docker Hub account. So you can see I am basically logged in inside my account. So these are the repositories which I have pushed on the Docker Hub. Maybe if you will log on, it may be possible if you will log in first time on the Docker Hub account, you will get some different UI, right? Now, over here, we are getting a search icon. So here we can search on our images. So suppose I want to search an image of Nginx. I will type Nginx and hit enter. Right now, I am getting all the results of Nginx image. And you may be surprised, I am getting close to 43,000 results of Nginx images. So it means on hub.docker.com, we have total 43,000 plus images, which is nginx image. So this is a question how we will identify the image which we can use. So always remember the first link, most probably the first link, you will get the official image, which is a single word image name. You can see this is the only image which is in the single word image name. Rest all of the image you can scroll, they are basically have some slash bit before the image name. See, and over here we are getting the description which is saying official. This is another image which is jwilder nginx proxy, and over here it is getting public and automated build, so it has the description as well. But we are getting only one image which is the official image. Also we can see this image has 10k plus stars and 110 million plus downloads as well, right? Suppose I want to explore this image, so I need to click on the details. Once you will click on the detail, you will get all the details of this particular web images. So this is the benefit with the official Docker images. With the official Docker image, you will get the proper documentation, right? So over here, I'm getting the official repository. Repository name is nginx, and here is the star. If you will click this star, then you basically marking this image is helpful, right? Over here, we are getting different tags and the repo info. So short description is official build of the nginx. Now we will talk about the tags and respective Docker file links. So basically these things which is being mentioned over here, these are the versions. So 1.15.5 is the version of official Docker nginx stretch file, right? 1.15.5 is the Perl specific, and Alpine specific is 1.15.5.alpine, right? We have the stable as well. We also have the stable release as well, and stable release is also available for the stretch, for Perl, for Alpine. Over here we have the quick reference links as well, architecture we are supporting, and a short description, hosting points, how you can execute this image like the external ports, internal ports, and complete configuration. So in the description of the official image, you can find a lot of things. So I would recommend you to go with this particular description and learn about the complete documentation of Docker images. It will help you to understand the Docker image and many other things related to the Docker image. Now let's go back to the image and let's click on this particular explore link. So once I will click this link, so basically you will get all the official image which is being supported by Docker community. So here we have few images which is being supported by the official Docker community, which is nginx, alpine, busybox, redis, httpd, apache server, mongod, ubuntu, postgres, node.js, mysql, and a lot of things over here, right? So these are the images which is basically supported by the official Docker community. We have the software engineers, developers in the Docker organization which is basically monitoring these images, which is basically developing these images and have a fully tested image for the customer. Now let's discuss how we can download the image. So to download the image, you need to execute a command docker pull, then the image name. But we have already seen we have a different versions available for the image. So suppose we have a requirement to download a specific version of an image, then how we can download it? So we can download the specific version of an image with this command docker pull image name colon then the version name. So let's see how we can download the images. So I will go to my hub.docker.com, and suppose I want to download my MySQL image. So I will open MySQL official image, and over here I'm getting the complete description of my MySQL. So by default, when you will download the image on your Docker host machine, it will directly download your image from the hub.docker.com. You don't need to configure any URL inside your Docker engine or Docker hosting machine. This is already pre-configured inside the Docker that when you will pull an image, then by default it will pull the image from the hub.docker.com. So I will go to my Docker hub machine and execute a command docker images to list out all the images, and these are the images which is basically available, and I don't have any MySQL image right here, right? Now suppose I want to pull out MySQL image, right? So I will execute a command docker pull and image name which is MySQL. Just hit enter and basically it will start downloading of your latest MySQL image. See, it is being downloading the MySQL image and very soon the process is completed. I will clear out my console and again execute the command docker images. So you can see an image of MySQL is being downloaded, and it is being downloaded latest image of the MySQL. And over here we can see the total size of MySQL image is 485 megabyte, right? Now I will go to my official page. So this is the latest image which is basically downloaded, and this is 8.0.13. Now suppose I want to download some older images. I want to download the MySQL image of 5.7. So I will go to my Docker hub and execute command docker pull image name colon the version, right? Hit enter. So you can see 5.7 pulling from the library MySQL. So it is basically downloading the 5.7 and it's done. If I will clear out my console and again execute the command docker images, so we can see I have two repositories or two images of MySQL. One is latest and another is 5.7, and we have a pretty much difference in the size of both images, right? So this is the way how you can download the image from the official Docker Hub site, right? So Docker Hub is just like a GitHub where you can basically put your images and you can download or check out the images. We have already seen the differences between the official and user images, the base and child images. We have discussed about the complete configuration of the official, the version of the official images, right? So thank you, team. Thanks for your time. Hello, team. Welcome back. And today we will discuss about Docker images and their layers. So let's start with. So in real time, Docker images is basically a series of layers, and Docker used the union file system to create the layer and then combine them to create a single unit or to create a single image. Each layer have their own specific use, and each layer is have a union file system which is independent from the other part of layer. So if we assume that a Docker image contains a 5 layers, like a 5 layer of union file system, then the base file system is a independent unit, right? It is an independent unit which don't have any dependency on the other parts. The layer 2 will have the dependency on the layer 1, and in the series the layer 3 have the dependency on layer 2, layer 4 have the dependency on layer 3, and layer 5 has the dependency of layer 4. So these are union file systems. They have their own work. Plus, if layer is the base layer, if the layer is the base layer, then it don't have any dependency, but the upper level layer have the dependencies that lower level layer should be present to work or to run the Docker image, right? The union file system allows files and directories to separate file system known as branches. So basically union file system is something where we will club out a particular utility with the dependencies and we can execute them. If you want to get a layer of an image, then you can use old command docker history then the image name. This command will show you the different layers, the commands used in each layer and exact size of each layer in a Docker image. So we'll go to our terminal. In a terminal, first we list out all the Docker images present on my Docker hub. So I will execute Docker images command and it will list out all the images. So over here we have different images. Suppose we want to get the layers of MySQL latest, right? So I will go over here and type Docker history. After the Docker history, I need to enter my image name and I will enter my SQL, hit enter. Then you can see I'm getting a pretty detailed output over here. So these are different layers which this particular image, MySQL image, contain. So you can see this image, the base image is basically updated 12 days ago, right? But the latest was updated 3 days ago. So basically this is the base layer. So by this we can see the most updated layer will be present at the top, right? And the least updated layer will be present at the base. This is the layer basically which was updated earlier, and this is some kind of add file which have 56 megabyte size. After then we have a command bash, then group add -r mysql user add something, and you can see there's a different layers for each command and each images and each file. So this is a separate union file system. This is a layer 2 which have their own file system. This is layer 3 which have own file system, layer 4 which have own file system, and so on. So right now, many of you may not be able to understand it, but once we will create our own image and we will build it, you will get it thoroughly, right? So team, by this way, you can find out the layers of an image. Suppose we want to find out the layer of nginx, then you can execute command docker history, enter nginx, hit enter. Then you can see the nginx command have the different layers, right? There is a file which is 55.3 MB. So basically the base layer is an Ubuntu system. This is the Ubuntu library. After then, in the next layer, it will go to the bash, then executing some commands, right? We can see. So this is the base layer. Then we have different layers, and we can see the layers present in the MySQL are different from the layers present in the Nginx. Now, if you want to find out a complete metadata of your image, then you can use the command docker inspect. After the docker inspect, you can enter your image name and hit enter. So basically it will show you the complete metadata of your image. It is showing the ID of your image, then the repo tag which is MySQL latest, then some repositories, parent, comment created at this particular time, and other information. Over here you can get the complete information of your image. The path is user local sbin, user local sbin. MySQL major version is 8.0 and MySQL version is 8.013 Debian based system. And you can get the other details as well. So if you want, you can go through the complete inspect command and you can find out a detail about your image. So that's all about the Docker image and their layers. In the coming lectures, we will see how we can create the layers and how we can build out a custom Docker image. So thank you team. Thanks for your time. Hello team, welcome back. And today we are going to discuss about Docker images tagging, or we will see the importance of Docker images tags in Docker. So let's start with. So very first, we will try to understand what exactly are the Docker tags. So Docker tags are just like a version of your image, right? Whenever you perform a git commit, you define a particular specific message and git specify a commit string with your commit. So in the same way, Docker tag is basically a version of your image that convey a useful information about the specific image, version, or the variant. So basically when we are saying we are tagging a particular image, then basically we are defining the version of that particular image of Docker file. Docker images don't have the name. So basically Docker images don't have any name. If you will execute a command Docker images to list out all the Docker images, then you can see we don't get any column like name. Let's see. So we are on a console, execute a command Docker images. See, we are not getting any column specifying the name. We are getting columns like repository, tags, image ID, created, and size. So repository is the name of parent directory, which is the name of file system you have. And tag is specifying the tag of that particular repository. Image ID is the ID which is being generated when you push your image over the Docker Hub. So basically Docker images don't have any name. So what is the combination of the Docker image and tag? So tag always associated with the latest image ID. So tag associated with this particular image ID. So this particular image ID has the tag 5.7. This particular image ID has the tag latest, right? So Docker images don't have their name. This is the repository. This is not your image name, right? So tags specify with the image IDs. Now next question which may comes in our mind, so how we can tag the Docker image? So there are two ways. First, you can tag the image when you are building your image, right? So during the building process of your image, when you are pulling your image over the internet, over the hub, then you can specify the tags. And the another way of tagging is with the help of Docker tag command. So image can be tagged explicitly as well with the help of command like Docker tag. For this, you need to execute a command Docker tag, specify your image with a specific tag. It is optional, and specify your target image name with a specific tag. This is also an optional. So let's see how we can execute this command. So we'll go to terminal, and over here we can see we have a list of images. See, right? We have a list of images. So we have an image Ubuntu. We have a single image of Ubuntu, right? Now suppose I want to tag my Ubuntu image with the specific name. So I will execute a command docker tag, specify the source image name, which is Ubuntu. Now you can need to specify the target image name. Suppose I'm defining Ubuntu test. Hit enter and it's done. If you will again execute a command docker images, then you can see a new image is being created, right? A new images is being created with the same name like we provided, Ubuntu test. This has the same size because we copied that particular image and renamed it. And you can see once we didn't specify the tag after the image name, it took the latest. So suppose you want to create a specific tag, then you can use a command like this docker tag, and suppose I want to tag MySQL 5.7 image. So I can see MySQL 5.7 is present in my local. I can tag it like MySQL Anshul dot test, right? Hit enter. Again enter the docker images command, and you can see a new images with custom tag test is being created, which is similar to MySQL 5.7. So by this way you can explicitly tag an image. Let's move to our next page. So now we have another question. When you don't specify the docker image tag, so what happens when we don't specify the docker image tag? So we have already seen, if we are not defining any tag with the docker image, then by default it takes the latest tag, right? So docker has the implementation, if you are not defining your custom tag, then it will tag the default tag latest with it, right? But it must be tagged in a docker. Now we need to understand the consequences if we are not defining the tag. So in the previous lecture, we have discussed about the Docker image layers. Now suppose you are working on an application and you are creating the Docker image of your application. And your application is using Ubuntu Debian base system in a base image. So you need Ubuntu Debian base image as a base image in your application. Now we assuming that Ubuntu is not providing the tag with their images. Then you need to choose the Docker Ubuntu latest image in your base image, right? So every time when your customer build your images, it will download the Ubuntu latest image. And if Ubuntu is pushing their code regularly on their images, then it may possible at some extent your application will be break because your code is not tested with the latest code of the Ubuntu. But if Ubuntu is providing a tag with their images, suppose Ubuntu is providing the tag like 3.0, 3.1, 3.2, and you have tested your image with Ubuntu 3.0. So you will specify that image 3.0 in your base image. So every time your image will be built with your customer, then it will download the tested image of the Ubuntu instead of the Ubuntu latest. So there is a lot of benefits of using the tagged in a image. It will help you to maintain the version of your system. It will help you to maintain the production like image, testing like image, staging environment image, or QA environment image. So you can specify the image tags. With the help of the tags, you can specify the version which may be compatible with the different kind of environments. So maybe one of your image may be compatible with the production environment, one of your image may be compatible with the testing environments, one of your image may be compatible with the Mac OS, one of your image may be compatible with the Linux, maybe one of your image may be compatible with the Linux Ubuntu base, one of your image may be compatible with the Linux CentOS. So there could be a different kind of application which is required over here. So it is the best way to tag your image. If you are tagging your image, then you are maintaining a specific versions of your image which is fully tested and qualified by your testing team. So this is the benefit of using the tags in an image. Thank you, team. Thanks for your time. Hello team, welcome back. And today we will see how we can upload a Docker image. So we have already seen how we can download the Docker image, how we can tag the Docker image. Today we will see how we can upload our local image to hub.docker.com. Let's start with. So to upload an image to hub.docker.com, first you must have the account on hub.docker.com. So first I will open out the Google and check, do I have the account on hub.docker.com. So on a Google, I will type Docker Hub, hit enter, and very first link you will get about the hub.docker.com. I will click this link. If you don't have the account, you need to create your account over here, right? If you already have an account, click on the sign in button and verify your credentials. So I will enter my email ID as a username and then I will enter my password. So we can see we have successfully logged in my account. So we have seen we have an account on hub.docker.com. If you don't have the account, you need to create the one first. So Docker Cloud uses Docker Hub as its native registry for storing both public and private repositories. So it means Docker Cloud is using the Docker Hub as a native repository for its all the private and public images. Once you post your image, it will be pushed on the Docker Hub and they will be available for the Docker Cloud to use. So again the question comes in how we can upload the images on docker.com. For this, first we need to enter a command docker login from a terminal. What it will do, it will ask you to enter the username and password. So basically over here you need to enter your dockerhub.com password and username, right? Once you will successfully log in, you need to enter a command docker image push your username which you have on a hub.docker.com and then your image name which you want to upload, right? So let's see how we can upload an image on a hub.docker.com. So we are on our terminal and first I need to list all the images which is present on my Docker machine. So I will enter command docker images and here is the list of all the images which I have on my machine. This is the image which we have created in the previous lecture. And suppose I want to push this image on hub.docker.com. So I need to enter the command docker image push, then provide my image name which is Ubuntu test. Hit enter. So you can see it is preparing to upload my image on my hub.docker.com. But at the end, I'm getting the error denied, request access to the resources denied. So first I need to set up a authorized session with my hub.docker.com. For this, I need to enter a command docker login. Hit enter and it will ask you the username of your hub.docker.com account. For this, you need to go to your hub.docker.com account and over here you are getting your username. In my case, my username is Anshul DevOps, right? I will again go to my terminal, enter my username, hit enter. Now I need to enter my hub.docker.com password and it's done. It is saying Warning, your password will be stored unencrypted in this particular file. Configure the credential helper, remove this file. Login success. So if you will see, you will get your password at this particular location. If I will show you cat, then enter this location, config.json, hit enter. Then you can see over here you are getting a JSON, and in this JSON we have the authorization key. So this is my authorization key, right? So if this key will be lost, if you lost this key, then anyone can log into your account, right? So if you are using in a secure environment, in a production environment, then after your upload, you have to successfully remove this particular key. And how we can remove this key? You need to execute a command docker logout. It will automatically remove this particular key, this particular JSON from your machine, right? Now I will try to upload my image with the command we was executing earlier. For this, I will clear out my console and again execute the command which we was executing earlier. So I will execute a command docker image push, then my image name, hit enter, and you can see it is pushing my image over the hub.docker.com, and it is saying requested access to the resource is denied. Why it is not uploading my image, right? It is not uploading your image because your image naming convention is not correct. If I will again tag this image in this particular way, docker image tag ubuntu, this is my source image. Now I will tag Anshul DevOps slash Ubuntu test or anything, whatever you want, right? Hit enter. Docker images. So you can see a new image Anshul DevOps slash Ubuntu test is being created. And if I want to upload this particular image, then I would be able to enter command docker image push, enter the particular image name, right? Hit enter, and you can see it is uploading your image. So what is the reason why it was not uploading my earlier image and why it is uploading my current image which I just renamed? And it's done. It's all done, right? Now we need to understand the reason. So we have already discussed about it when we was discussing about the official image and when we was discussing about the unofficial image. So for this, I need to go to my hub.docker.com, and suppose I will refresh my browser, then you can see a new image will be present over here. See, Ubuntu test is being present over here. Over here, we are getting the latest image which I just uploaded. Why it just accepted this name Anshul DevOps slash then the image name? Why it was not accepting the Ubuntu test? Because single word image name is just allowed to the official image of the Docker. If you will search for any image like Ubuntu, then you can see a single word name is just allowed to the official images. This is official, this is official, this is official. Rest all of the images will be with the slash, and before the slash you have the account name, and after the slash you have your image name. This is the same reason I was not able to upload the Ubuntu test this image, and I just uploaded Anshul DevOps slash Ubuntu test, right? So this is the important point which we need to remember when we are creating the image. Now I will explore my image. So I will go to my hub.docker.com, go to dashboard, and click on the details of the image which I just uploaded. So over here I'm not getting any description, I'm not getting anything else because I know I didn't provide, right? So right now we are just testing how we can upload the images. In the future lecture we will build our own image and we will upload it, right? I will go to the tags, and you can see this image was pushed 2 minutes ago. Then over here I'm getting the latest tag. Over here I'm getting the latest tag, but you can see at the time of upload I didn't provide any tag. So by default it took the latest one. Now suppose if I will change the tag of this particular image, I will again execute the command docker image tag. specify my image name, then again specify my image name, but with a specific version like 1.0.1. Hit enter, clear out my console, again execute the command docker images. So we can see another image with the tag 1.0.1 is present over here, right? But you can see the id of all these images are same because they are just copied with each other, right? I will again push my image, docker image push, specify my image, put colon, specify my version 1.0.1, hit enter, and it's done. Now here we need to notice a major update. Over here I'm getting a message, layer already exists, layer already exists, layer already exists. This is the thing which I didn't get when I first time uploaded my images. So by this way we can understand docker internally verify that where is the change, and we don't have any change in the layers, we don't have any change in our file system, so it will not upload the earlier file system to the hub.docker.com, and same mechanism will be applicable for the download as well. If you are downloading some image and it don't have any change in their file system, there is a change in the version or in the tag, then it will not download the all layers or the complete image. It will download only that part which is different from the previous one or which is different from the existing one, right? If you will change anything in the file system and you will upload it, then it will show you the change over here, right? But you didn't change anything in the file system, that complete file system is present on the hub.docker.com. So quickly docker identified the image is same, it's just there is a change of the tag, it just uploaded the same image with the tag. So at the runtime it just changed the tag, the image data is same, and this is the most optimized way to keep the images, right? Now if I will again go to my hub.docker.com and refresh my page, so you will get another tag over here 1.0.1, right? So the same image is present with the two tags, the two versions. First is latest and second is 1.0.1. So this is the way how you can upload your images. This is the way how you can log in to your hub.docker.com from the console, right? Now suppose I have done my job, so I will execute a command docker logout. Hit enter and see removing login credential from this particular location, right? If I will again show you cat root.docker.config.json, hit enter, then you are not getting your authorization key. Your key is being removed. So always remember, when you log in to your account from some unknown machine over unsecure networks over some other servers, then you must have to log out your account to remove your authorization key, otherwise it will be misused, right? So this is the way how we can upload our own images on the hub.docker.com with different versions, with different names, with different tags, and what data is actually being uploaded on the hub.docker.com. If data is already exist there, then docker identify the differences and it will upload only the difference or the delta. So thank you guys, thanks for your time. Hello team, welcome back. This is a new section where we will learn about how we can build our own custom Docker images. For this, first we learn about the Docker file. Docker file is a file which will be used to create the basic images or the custom images. In the Docker file, first we will go through the basics of the Docker file, like what is the Docker file and what is the use of Docker file to create or build your custom images. So when we are talking about the Docker builds, we are talking about the Docker images, then Docker can build the images automatically by reading the instruction from a Docker file. So first, to create the image, we need to define a Docker file which have all the instruction which is required to create the build automatically. This Docker file is a text document which contain all the commands and the instructions which is required to create the Docker image, right? These commands can be called by the user on a command line as well. A Docker image is nothing, it is just a read only layers which is basically defined inside the Docker file. So in the form of instructions, Docker file have different layers, and these layers will be used by the Docker to create the Docker image, right? And Docker image will only contain the delta. We have already discussed about it when we was updating our last image on the hub.docker.com. Then we have seen the unchanged part of the Docker image was not uploaded, right? We have seen when we change the version and uploaded the image again, then we get the message layer already exists and layer already exists. So it means Docker will automatically consume the delta, which is a difference between the current image and the previous version. If we want to create a Docker image from a Docker file, then we need to execute this particular command. We need to execute docker build -f. Then we need to provide the path of my Docker file in my machine. So this is the very basic introduction of the Docker file. Now we will learn about the format of the Docker file, in which format you can create the Docker file, what are the options available inside the Docker file, how you can build your own images with the help of the Docker file, and we will also go through some official Docker files which is available on the hub.docker.com. So thank you guys, thanks for your time. Hello team, welcome back. And today we are going to discuss about different instructions defined in the Docker file. So let's start with. So we have already discussed that Docker file have the instructions that are used to create the Docker images. To understand the complete concepts of the Docker instruction and Docker file, first we will see an sample Docker file on hub.docker.com. So for this, we need to go to Google and type Docker Hub. Open the Docker Hub website and log in your account. So we are on the hub.docker.com dashboard. Over here, we can search for any official image, suppose Hello World. So this is the official image of the Hello World program. I will go to details, and in the details, in the sample tags, we are getting a link of Docker file, right? So if I will open the Linux Docker file in a new tab, then it will open the GitHub location of your Docker file. So this is the content of the Docker file which Hello World application have, right? So over here we have instructions like from, copy, and cmd. If we again go to the hub.docker.com and search for another, if we again go to hub.docker.com and search for another image like Tomcat, hit enter. So here is the official image of the Tomcat. I will go to details, and inside the details we have a different images. So suppose I want to open the Alpine version Docker file. So I will click this link, and in the new tab you can see over here a Docker file of Tomcat Alpine version is being opened. You can see, right? This is the complete Docker file of Tomcat Alpine version, and here we have the different instructions like from, env run, work dir, env, then again the env, then run, right? So these are the instructions. So the things or the commands which is displaying in the red color are the instructions of a Docker file. Now we will learn about these one by one, right? So very first we will learn from the from instruction. So from instruction initialize a new build stage and set the base image for subsequent instructions. What does it mean? So in every file, from instruction will be the basic instruction, and that must be present in every Docker file. So from should be the first instruction which will be defined inside the Docker file, which will create the base image for the subsequent instructions. right? So valid Docker file must start with the from instructions. So if you are not starting your Docker file with the from instruction, then definitely you are implementing an invalid Docker file. With the help of the from, we can download the base image over which my image will be built, right? So to build a Docker image, first we need a base Docker image, and this base image can be any valid image, like it could be the Jesse Linux image, it could be the Alpine, it could be the Debian Unix system. So from, with the help of the from, we are basically mentioning a specific image and a version which will be used as a base image to execute the subsequent instructions. Format of the from will be like this: from, then we need to define the image name, colon, then the tag, right? It means the version of that particular image. So from is the very first instruction which we need to mention in every Docker file. If we again go to the Google and open up the link we have opened, so you can see this is the Tomcat Docker file, and very first line is from. And in the from, what it is doing, it is downloading the OpenJDK 7JRE Alpine image, right? So this is the base image to execute any subsequent image which is present inside this particular Docker file, right? So this is the very important instruction in any Docker file. From is a very important instruction in any Docker file. Now let's learn about the next instruction. So next one is the label. So label is something which add to image to organize the images by project or recording of the license information, right? So label is something we are defining label for my image. It could be anything, right? And for each label we need to define some key value pairs. So there could be the example like this, like we are defining a label com.example.version, and the version is 0.0.1 beta, right? We can define another version like the vendor, and vendor is ACME incorporated, right? So with the help of the label we are defining the key value pairs, which is a metadata of my image. Now next instruction is run, which is another important instruction in a Docker file. Run instruction will execute any commands in a new layer on top of the current image and commits the results. So what we are getting from this particular statement? So there are two things. First, with the help of the run, you can execute the command on a current image, right? The current image means the image which is already built with the Docker file, right? And it will commit some results. So suppose we have a Docker file in which first we define the from, then we define the run, and inside the run we are executing some Linux commands, right? So these Linux commands will be execute on that particular base image, and the resulting commits image will be used in the next step of the Docker file. So what is the output or what is the throughput of the run command that will be used in the next step of the Docker file? So we can take an example here. Suppose we are downloading the Ubuntu 14.0 from, then we are executing a then we are executing a command apt get update, where we where we are basically updating the packages of my Ubuntu with the help of a run command. Then I will again execute a run command to install the curl on my Ubuntu base image 14.04. So with the help of the run, we can execute the commands on our image, right? And the output of the run command will be used with the subsequent instructions in a Docker file. Now the next important command is the CMD, which have the equal weightage in the importance as the from command. So CMD instructions should be used to run the software contained by your image along with any arguments. So with the help of the CMD, we are basically executing the container. We are basically executing the application inside the container, right? The application which we have built inside the image, with the help of the CMD, we are executing that application. And inside the CMD, we need to define the executable commands and what kind of arguments my application is accepting, right? This could be the format of the CMD. Then we define the executable, then can be defined n number of parameters which basically will be accepted as an argument by my application, right? There can be only one CMD instruction in a Docker file. So this is the another important point. Like we have one from instruction, which is the first instruction in my file. In the same way, cmd could also be one, and cmd could be the last instruction in my Docker file. If we have two cmd instruction, then the last one will be execute, right? Last one will take the effect. The main purpose of the cmd is to provide the defaults for an executing container. So with the help of the cmd, we are defining the commands which will execute my application with the default parameters, right? If there are some hardcode parameters required, we can define this parameter inside the cmd as well, else we can ask for these parameters from the user as well. Now we will talk about the expose. So expose instruction indicates the port on which the container listen for the connection, right? So with the help of the expose, we can define the ports where my application will execute. So we have seen when we was running the nginx, we was running the nginx on port 8080. So that port 8080 or port 18, which is internally a container is running on, that can be defined with the help of the expose. After the port, you can also define the protocol over which protocol that port will be opened, right? The format of the expose would be like this: expose, then you need to define the port. Now the next thing is the environment. So environment is the instruction to set environment variables for your application, right? So with the help of the environment, we can define the environment variable for my application. That could be anything. That could be the path of some specific things, that could be the username, that could be the password, some default password. Anything which is anything which my application is treating as an environment can be defined with the help of the environment instruction, and the value of the environment instruction should be key value pair, right? As we have discussed, that environment will be used to update the path environment variables for your software inside the containers. Now another thing is the add. So add instruction copies new files or directories or remote file URLs from source location to your file system, right? And the default format of the add would be like this: add, then you need to define the source, then you need to define the target. So with this particular command, add all the files starting from home to my dir in my containers, right? Now the next one is volume. So volume is another important instruction inside the Docker. With the help of the volume, we should define expose the database storage area. We can define the mount points of my application. We can define the configuration of the storage. We can define the file folder created with the Docker file containers, right? With the help of the volumes, we can also define the persistent data location and the mount points. So if you are not able to understand the persistent data and mount points, we will discuss these things in very details when we build our own images. Another thing is the work dir. So as the name is self explicit, work dir means my working directory. So work dir instruction sets the working directory for any command like run, cmd, add instruction, and it follow the Docker files, right? So these are the instruction which basically an important instruction to create any Docker file, right? Now suppose we also go to the our Docker file of Tomcat and we will try to understand it. So here is the Docker file of my Tomcat. So we can now we can understand it. With the help of the from, we are downloading the base image of the OpenJDK, and the image tag is 7gre pipeline. After that, I defined some environment variable like Catalina home and the location of this user local Tomcat, path Catalina home, and bin, right? This is the path of my bin directory. Then I defined a run command, make dir -p $Catalina home. So I'm basically creating this particular directory, right? Then I defined the working dir with the help of the $Catalina home. So this the bin would be my working directory, right? Now again define two environment variables, Tomcat native library and LD library path. So these are some internal paths. Then we again have the environment variable like this is some GPG key. I'm not sure I'm not sure what it's all about, right? Then another have the environment variables like Tomcat major, Tomcat version, and again some environment variable like Tomcat ZZURL, Tomcat SCURL. Then have the run, right? And inside the run, we are executing these commands. So if you have a long command, you can divide your command with the help of slash, right? Over here we can see with the help of the slash, the command is being divided into the parts, right? Once the run command will be execute, it is executing another run command, right? And exposing the tomcat by default on port 8080C. And after then it is executing cmd, and inside the cmd, what is my executable? My executable is catalina.sh, and what is the command or argument it will accept? Run, right? So once I will start my tomcat container, it will execute catalina.sh. That's it. So this is the sample Docker file, and you can see here we are getting a lot of instructions we have already learned in the same tutorial, right? So this is the sample instruction and significance of every instruction we can have in the Docker file. So thank you, team. Thanks for your time. Hello, team. Welcome back. And today we are going to discuss about how we can build our own custom Docker images. In the previous lectures, we have seen the Docker file. We have seen the default commands which is present inside the Docker file. Today, we will use that Docker file and we will create our own custom image. So let's start with. So we have already discussed about this in the previous lectures. To create the Docker images, we need to create the Docker file first. So in this particular lecture, first we create our own custom Docker file, and then we will see how we can create an Docker image from that Docker file that can be run as a container. Now we need to discuss about the syntax of Docker build command. So here is the Docker build command, docker build -t. Then you need to specify your image name, then the tag name, and then the directory where your Docker file currently presents. Now we will understand the detailed explanation of Docker build command. Here -t is stand for to mention the tag after the image. Image name is the name of image which you want to provide to your image. You can provide it anything like nginx an image, mysql an image. So you can provide any custom name to your image. Then you need to tag that image. So if you want, you can specify the version. If you want, you can specify some custom tag to your image. After this, we need to provide the directory where my Docker file present to build that particular images. If your Docker file is present inside the current directory, then you can mention period like dot. If your Docker file is not present inside the current directory, then you need to specify the path of your Docker file inside your command. So very first, we will create our own custom nginx image and execute it. But before create any Docker file, we need some kind of editor where we can create or edit the Docker file. For this, in this particular training section, we are going to use the Visual Studio. So Visual Studio is a code editor tool which is being provided by the Microsoft, and in the recent days I am finding it a very suitable and very popular code editor, right? Visual Studio Code can be used by any kind of programming language. You can use the Visual Studio Code with the C, C++, Python, Ruby, PHP, even with the Jenkins file and Docker file. So first we will see how we can use the Visual Studio Code. To use the Visual Studio Code, we need to download this Visual Studio Code from the given link, or you can go to Google and type download Visual Studio, right? So I'm on my browser, I will type download Visual Studio. You will get a lot of links. Over here, you are getting a lot of links to download the Visual Studio. And the very first site is the Visual Studio official site, which is visualstudio.microsoft.com. I will click over here, and from here you can download the Visual Studio community version, which is free, professional version, enterprise version, and Visual Studio Code free version as well. So I will go with the community version, right? And I will download it. It will download the executable file on your machine. You need to extract that package and install the Visual Studio in your machine. I already have the Visual Studio in my machine. So I will open the Visual Studio. So once you will open the Visual Studio, you will get a UI like this, right? So this is the welcome page which you will get once you will first time open the Visual Studio. So in the Visual Studio, you will get a different kind of options. By this, you can open the File Explorer. Over here, you can search for any kind of plugin which is required to run your code in the Visual Studio. This will support the Git control. This will support the debugging of the files. And over here, you will get all the extension which you have installed inside your Visual Studio. So right now, I have the extension like Docker, Python, and SQL Server, right? So if you want, you can uninstall the extension. So suppose I want to uninstall it. So I will uninstall the Docker extension, right? And it's gone. So if you want to create the Docker file, then you need to install the Docker extension in your Visual Studio. For this, you can search for the Docker, press enter, and you will get a lot of options like Docker Explorer, Docker Runner, but I will go with the official one, and you will get the official one from the Microsoft, right? So over here you can see this is being provided by the Microsoft, and this is the official Docker extension from the Microsoft. If you want, you can click this install button to install the Docker extension in your Visual Studio, or you can install by this particular install button as well. So I will click this, and it will install the Docker extension in my Visual Studio code, right? If I will again go to the extension and I will minimize this search, see, Docker extension is available on my machine, right? Now, what I need to do, I need to create a Docker file. So I will open up the folder and I will go to any directory on my machine. So suppose I will go to users, my directory, and over here I will go to training, I will go to Docker and build Docker images. So suppose this is the directory where I want to create my Docker file. Over here, I will click this particular link, new file, and I will create my Docker file. So I will mention Docker file, hit enter. So you can see, as I mentioned the Docker file, a Docker icon is being presented over here. A Docker icon is being present over here, right? I will open up the Docker file, and here I need to mention all the things, all the commands which I want to run inside my nginx. So very first command is from. So you can see once I started the typing, I am getting the autocomplete. I will hit enter and it is being completed automatically, right? So over here I need to mention the base image. So I will mention Ubuntu. So I will mention Ubuntu. Then I need to define the Ubuntu image version. So I will mention Ubuntu latest, right? After this, I want to mention some label. After this, I need to mention some label. So if you are not getting the autocomplete in your Visual Studio, you can press Control space to get autocomplete in your Visual Studio. Over here, suppose I need to define the key, which is version, and I'm defining the version is 0.0.1. Again, define the another label, and suppose I'm defining maintainer, and inside the maintainer, I'm defining my email ID. Now, what I did, I started my image from a base image of Ubuntu latest. Then I defined the two labels, the version of my image and the maintainer of my image. Right now, I need to define some run, right? And over here, I need to define the run command of apt-get update and apt-get install. So first, I will update my Ubuntu packages. So over here, I mentioned the command apt-get update and apt-get upgrade followed by -y. Why am I mentioning the -y? So that it will not ask me the permission at runtime. Now I will mention another run command, and over here I will install the nginx in my Ubuntu base image. And in my next command, I will install the nginx on my Ubuntu base image, right? So I will insert a command to install nginx. So it is apt-get install nginx followed by -y again. -y so that it will not ask the permission at runtime. Then we need to expose some port where my container will accept the traffic in a nginx. So we'll enter expose. and suppose I want to expose port 80, right? So at port 80, my nginx container, this is default container which we are creating right now. So it will accept the traffic on port 80. If you have any confusion, you can accept the traffic on any port, right? Like 90 or anything, whatever you want, right? After this, I need to insert the last command, which is cmd, right? And here I need to define the commands to start my nginx container. Over here, I need to define the commands nginx -g and the dminf mode. So you can see this is our custom Docker file to create the custom nginx container. I just need to save it. Now I need to go to my terminal. On my terminal, I will execute command docker ps to verify is there any container running. On my terminal, I will execute a command docker ps to verify is there any container running on my machine or not. And you can see one container of nginx is running on my machine. So first I will stop it. So docker stop, then the container id or the container name. My container name is awesome swords. Hit enter. Again execute docker ps and it's gone. Now we need to create our own image. But before this, we need to verify that how many images is present on a machine. So we'll execute docker images. And right now only one image is present on a machine and the repository name is nginx, tag is the latest, right? So now we will create our own image by command docker image build -t. Then I need to specify my image name. So I will specify this custom nginx colon. Now I need to specify the tag. So I'm specifying 0.0.1. Now you need to define the path of your Docker file. So my Docker file is present at a root directory. So I need to define the path like this. That's it. And execute this command. So the command is docker image build -t. This is my image name. This is the tag which I want to attach with my Docker image. And this is the directory of my Docker file. Hit enter button. And you can see it started building your custom Ubuntu images file, right? And all things are being processed. So we have to wait until the complete processing will be done and it's all done, right? Now we need to move one by one. So we will go to the starting of this processing. And over here, you can see the step 1 out of 7 is started. So every instruction which is mentioned inside your Docker file over here, Docker will take it as a step. So this is the first step for the Docker. Label is another step. This is another step. So by this mean we have the 7 step in our Docker file. 1, 2, 3, 4, 5, 6, 7, right? And same information we are getting over here. That step 1 out of 7 is being executed. So first it is started from a step 1. And in the step 1, and what is the step 1? Step 1 is from Ubuntu latest. It downloaded the latest image of the Ubuntu. Then it started the step 2 over here and it defined the version. Then in the step 3, it defined the maintainer of that particular image, right? The next step is a step 4. Over here, we are updating our apt-get packages and it's done over here, right? Here we have the step 5. We are basically installing the nginx, right? So nginx took time. Then we have the step 6. We need to find out. See, over here we have the step 6. We expose our nginx at port 90. Then we have the step 7, which is the last step, the nginx cmd, right? If I will clear out my console, and after the processing I am getting the image is being successfully created. This is the image id and this is the image tag label, custom nginx 0.0.1. So I will clear out my console and again execute the command docker images. So you can see another image of custom nginx is being created over here. See, the size of my custom nginx image is 181 megabyte. If you want to execute this image, then you can execute it by docker run -d -p. You need to specify on which port you want to access your nginx. So suppose I want to access it on port 4444, then at what port the container will get the traffic, and we have defined the port 90, right? Then you need to define your image name, which is custom nginx, right? So this is the port which we can access the nginx from a host machine. This is the port where nginx will get the traffic, and we have modified the port to port 90, right? Hit enter. Uh-oh, we are getting the error message because we didn't define the version. This is not the latest ones, right? So we need to define the version as well. Hit enter and see, a container with this particular ID is being started. If I will execute a command docker ps, then a container is running. So this is the way how we can create our own custom images and how we can run our own custom images. Now suppose we want to change something in our custom image. So we will again go to over here, and suppose we want to expose the port 80 instead of 90, and I want to add something, some comments over here, right? So I will add some comments in my docker file. So I have added some comments over here before every instruction. So I have updated few comments over here in this particular docker file. So if you want to comment out something, then you can use hash to comment out the line. I have added the comment because I will upload this file in the resources of this particular lecture so that you guys can get it, right? And I have changed the port. So the only change which I did is just change the port from 90 to 80, right? I will save this file. After save my file, I again need to rebuild it. For this, I need to again execute the same command docker image build -t, then my image name, which is custom image, nginx, put colon. Now I need to change my tag. I will change it from 001 to 002, then define the directory where my file is present. So my file is present inside the root. Hit enter. And this time you can see it is quite fast. It doesn't take much time as compared to previous one. Why it is not taking the time? So this is the advantage of the docker. This is the beauty of the docker. That's why the docker is very fast in the deployment. So by default, docker identified where the change is present, right? And it executed only that particular step. It didn't execute any step which is not changed, where we don't have the change. So docker keep all the things from its own cache and rebuild a new image. So we don't have any change from the Ubuntu base image. So it's use its own cache, you can see over here, and didn't build this particular step. The step which is built is the only sixth step, you can see. Rest all of the steps are from the cache, right? And it is just building the sixth step where we have changed the port. See, removing the intermediate container, this, and generating the new ID. It just build the step where the change is present. That's why Docker is so fast in the deployments. All the step which is being built previously is not being built again. So Docker is so optimized in building the images. So if you change anything in any step, then that particular step will be built next time when you will generate your image, right? Now I will clear out my console and execute docker ps. So our container is running. First I need to stop my container. So docker stop, then provide the container name, which is friendly Hensburg. I stop it. Docker ps. Oh, docker ps. And you can see only one container is running, which is nginx official container, right? Clear out the console. Now docker images, and you can see a new image is being presented over here with the new ID. Now, if we want to start our container on a new image, which is custom nginx 0.0.2, then we need to execute a command docker run -d -p. Then you can define any port like 8081 where the host can access this particular nginx, and I need to define 80 because in my new image the port is 80, which is listening the traffic, right? After then I need to define my image name .2. Hit enter, and you can see container is being started with this particular ID. If I will execute a command docker ps, then we can see the container is running, right? So we have started our container on a port 8081. Suppose we will go to our browser and try to access this particular container, right? So we are on a browser. Over here you need to mention the IP of your machine, then put colon and port 8081, because this is the port where we are accessing our container, right? So this is my machine IP. After then I put the colon and the port where I'm running the container, hit enter, and you can see nginx container is running. So team, this is the way how you can create your own custom images and how you can build your images and how you can execute your images, right? So thank you team, thanks for your time.
Hello team, welcome back. And today we will see how we can extend official Docker image and customize it. So let's start with. So today we are going to get the official Nginx image and we are going to modify it. So we will do some customization of the official Nginx image, then we will create our own image with the official Nginx one. Right? So let's go to the terminal. So we are on a terminal. So first I will execute ls. So in my current working directory, I have two files. The first file is the Docker file and second file is index.html. So what we are going to try, we are going to replace the official nginx image index.html with our custom one. So let's see what content do we have in our index.html. So in our custom index.html file, we have a single line text, and that text is also in a h1 format, right? So we are going to replace the index.html content of the official image from this custom file, right? For this we need to modify this docker file, right? So we'll go to our Visual Studio and modify this particular docker file. So this is the custom docker file which we have created in our last lecture. Today we will modify our Docker file a bit, again rebuild the image and use it. And today what we are going to try, we are going to extend the official nginx image and replace the index.html file with our custom index.html file. So to extend the official nginx image, first I need to modify my from. So in my from, I need to take nginx latest. Why I'm taking the latest? Because every time I will build my images, it will get the latest nginx image from the Docker Hub. Let's leave the versions and label as it is. We are not going to change anything. We don't need any run command, right? Because we are not going to execute something. Instead of the run, I will mention work dir. And inside the work dir, I need to provide the current working directory. So over here I need to provide the path of the index.html inside the official nginx image, which is user share nginx html. So this is the path inside the official nginx image where index.html file can be found, right? I will update my comment as well. After this, I don't need this run command and I don't need the expose port as well. What I need to copy my local index.html at this location. For this, I will use a command copy, provide the source is index.html, and the destination is also again the index.html. What we are trying to achieve, We are trying to replace the index.html file which is present at this location inside the official nginx image with our custom index.html image. Now you need to save your file, your Docker file. Now over here you can have few questions, right? You can see we are not providing the cmd command. We are not providing any run command. Why we are not providing any cmd command? Because the run command and the cmd command is already present inside the official nginx image. What we are trying, we are just providing the label, providing the working directory where we want to work. And what is the work? We are going to replace the official index.html file with my custom index.html file. That's it, right? So what it will do, this Docker file will build a new image which will execute, and once you access the nginx server, it will show you the default content which you have mentioned inside your index.html file instead of the official one, right? So let's see how we can build it. So we will back to our terminal, execute command ls. So we have only two things over here. We have the index.html file and we have the Docker file which we just modified. If I will show you the content of the Docker file, so you can see this is the content. So we have done these kind of changes in our Docker file, right? Clear out the console. Now we need to build this image. And how we can build the image? We have seen this in the last lecture. So we will execute a command docker image build -t, then provide the image name, put colon, and then provide the tag name. After this, I need to provide the directory where my Docker file presents. So my Docker file present at a root. Hit enter and you can see it's done. So it's pretty fast. Why it didn't take much time? Because most of the things was already present inside the cache. It just get the things from a cache, change few things and built a new image. So you can see latest nginx was also present in my local. So this was basically get from the cache. It just added the label, right? So first it added the label version, then added the maintainer, right? Then updated the work directory, then copy this. So just 5 steps are being executed in this particular image. If I will execute a command docker images, so I can see my nginx-custom version 0.0.1 is present over here, right? Clear out your console and let's try to execute our image. So for this I will execute docker container run -p, provide the host port 8080, provide the container port, then the image name, tag, then provide the version, right? Hit enter. Now you have started your custom nginx image. So to verify the change which we have done, we need to visit the browser. So we will go to the browser and paste our machine IP address in the address bar. So we are on a browser. Over here I will paste my IP address of my machine, then put colon, then port 8080 because I have started my nginx on port 8080. Hit enter. So you can see you are getting your text. Hi, thanks for being here. You're running the custom nginx. And we can see in the terminal as well that a new log is being generated over here. So every time I will refresh my page, refresh it again, refresh it again, refresh it again, and go to terminal. So see, every time I'm refreshing the page, a new log is being generated over here. So it means my container is working, right? By pressing the Control C, I can stop my container, right? Press ls and we can verify. If I will show you the content of index.html file, then this is the same content. Hi, thanks for being here. You are running the custom nginx. And we was also getting the same content on my browser. So if we again want to verify this, we can edit this file. So I will edit this file, right? Go to the insert mode. And suppose I'm going to insert some text as well, right? So I'm going to insert some new text. So I have added a new text in a heading 3. This is an official nginx image. We are building it for our personal use, right? I will save this file. Now what I need to do, I need to again build my image because my previous image has that particular index.html which was not modified, which was the custom one. We have modified our index.html, so I again need to build my images. For this, I will again execute the same command, docker image build -t nginx custom, and then I will update my version, and I will update it 0.0.2. Right, hit enter. So you can see only this step is being changed, rest everything from the cache, right, using cache, and we are getting cache over here. Just this step was changed because there was a change in the index.html. Clear out your console and again execute the container, but this time we need to update the build, update the tag. So we are executing the container nginx custom 0.0.2. Hit enter, go to your browser and refresh your browser and see this text is being appended over here. So our changes are working fine. So this is the way how you can create your own custom images, how you can extend the official custom images and change them according to you, right, according to your specific needs, according to your application, right. So we have seen how we can extend the official image, how we can change it, and how we can use them. If you want, then you can upload this image on your own account. For this, you need to modify this image name because with your account username is mandatory with the image name, and then you can upload it, right. So we have already discussed about it, how we can upload the custom images on the hub.docker.com. Thank you, team. Thanks for your time. Hello, team. Welcome back. Until now, we have discussed a lot of things about the Docker images. We have discussed about the Docker images. We have seen the format instructions of the Docker images. We have already built our custom Docker images. So today I am posting an assignment for you, which you need to complete before move further. And in the next lecture, I will post the answer as well. But before go through the answer, before go through the solution which I will provide, you must try to execute you must try to solve this particular assignment by your own, right, so that you can test your knowledge, you can practice it, and you can get more confident in building the docker images. So let's start with, so what we need to do, we need to create a custom docker file. So I'm expecting you will create your own custom docker file in which first you will get the latest python image from the docker repository, right. So we, in the previous lectures when we was creating our own custom images, so we was getting the images of nginx ubuntu. This time you guys need to get the image of the python. Then if you are aware of the python programming, then write down any simple program in the python language. If you're not aware of the programming, then you can get any simple python program from the internet, right. Save that particular file in your local machine. Then you need to run that particular python program inside the container, right. So first you need to write down or download the python program, save it in a file, keep that file inside the docker file, build your images, then run that image. After then, that particular file, the python file, should be executed inside your container. Then tag and push your images to the hub.docker.com. After this, remove the images from your local and again execute your image so that it can download the image from the hub.docker.com and execute it. So this is the assignment which you need to do before move further, right. So it's good for you if you practice this assignment. I will post the answer in the next lecture. Thank you, guys. Hello, team. Welcome back. In the previous lecture, I have posted an assignment for you. Today we are going to solve that particular assignment. So let's start with. So we have the assignment where we need to create the custom docker file which will get the latest python from the hub.docker.com, right. So we will see how we can do it. For this, we will go to our Visual Studio Code Editor. So this is the docker file which we have created in some previous lectures. So instead of, if you want, you can create the new one or you can edit this particular file as well, right. So very first I will remove this comment, it may be mislead many of you. So very first we need to get the latest image of Python. So in a from, I will remove the nginx from a Python. So I'm getting the latest image of the Python. After this, we can leave this as it is, like label version is 0.0.1 and label maintainer is Anshul Chauhan. So we will leave it, right? After this, let's forget about this for now. Before this, we need to create a custom Python script which will execute. So I have created an Python script for you. So here is the Python script which is very simple. So here I'm getting a variable n, which is the value of n is 15, executing a for loop, right? And then again executing a for loop. So this upper for loop is basically creating a parent, right? And this lower for loop is again creating the parent. So once I will execute this particular program, so this will create a pyramid like this. See, right? This will create a pyramid like this. So we need to execute this program inside a container. For this, I need to modify my Docker file, right? And what modification are required in my Docker file? So first I have defined the version of my Python. Now I need to add this particular file, my script file, inside my container. For this, I will use a command add. Then I need to provide the source. What is the source? Source is my script.py, which is the file name, which is my Python script file name, my underscore script.py, right? Then I need to provide the destination. So suppose I want to keep it at a root directory inside my container, right? After this, I need to provide the executable command, right? And to execute the Python script, you need to insert a command cmd. Then over here, I need to provide the parameters. So I will execute the Python program. So I will enter a command cmd python, then dot, which means the current directory, and my script name. That's it, right? So this is the custom Docker file which will download the Python latest image, define the maintainer and version, add your script at the current directory, and then execute your script. I will save this file, right? Now I will go to my terminal. Over here, I will execute a command ls. So we can see we have three files: Docker file, index.html, which we have created in the previous lecture, and myscript.py, which is present inside my current working directory. If you want, you can verify your Docker file content by help of command cat, then your file name. This is the same file which we have generated, right? Now I need to create the image of this file. How we can create the image? So to create the image, we can use the same command docker image build -t. Then I need to provide the name of my image. So I'll provide custom Python program, or say Python program. Then I need to provide the tag, which is 0.0.1. Then the directory where my Docker file is present, right? Which is present at a root. Hit enter. So you can see it is done, right? It's all done. So it has created and get everything from the local cache, right? I will clear out my console and execute a command docker images. So you can see a Python prog image is being created, right? And Python latest is also being downloaded on my machine, which is 923 megabyte in size, right? Now what I need to do, I need to execute this particular image to execute my program. For this, I will execute this docker container run. Then you need to provide the image name, which is Python underscore program, then the version, right? Hit enter. Over here, we don't need to provide any port or anything else because we don't have this kind of configuration inside the Docker file. We just need to execute a program which we have already defined inside our Docker file. Hit enter and it will execute your program. See, it is printing the complete diamond structure which we have programmed inside my script, right? So that's, so you can see how simple it is. You can execute anything inside the Docker, right? So we have completed till here. Now we need to tag and push our image on hub.docker.com. delete the image from a local and again execute from the hub, right? So let's go to the terminal. So to delete the image, first I will list out the images, right? And I will execute a command docker image rm remove -f for the force. Then I need to define my image name, which is Python program version. And suppose I want to delete this Python program as well, which is I just downloaded. Hit enter. So you can see the image and corresponding containers are being deleted, right? If I will again execute a command docker images, so I will not find these, right? Now what I need to do, I will again create the image with a specific tag and push it. Now what I need to do, so I will again create the image with a specific tag and push it to my hub.docker.com account, right? For this I will execute a command docker image build -t. Now to push the image on hub.docker.com, I need to start my image name from my hub.docker.com account name. For this, first I need to verify the account name of my hub.docker.com account. So I will go to Google and open hub.docker.com, click on the sign in button, enter my username and password and log into my account. Now your account name would be displayed at the top right side of your web page. So my account name is Anshul DevOps, right? So I'll go to my terminal and I will provide my account name, which is Anshul DevOps, then put slash, then I need to put the name of my image. So I will put Python underscore program, then put colon and the tag. So I'm putting 0.0.1, right? After this, I need to provide the path of my Docker file. Hit enter, right? Clear out your console. Enter command docker images. See, your image is being created. The size is 923 megabyte. Now we need to push this image on my hub.docker.com. For this, I need to execute a command docker login. I need to provide the username, which is my account name, which is Anshul DevOps. Provide the password, login success. Now I need to push my images. How can we push your images? For this, I will execute a command docker push, then image name with a specific tag, hit enter. So it is pushing my image to the hub.docker.com. So you can see all done, right? My image is being pushed on hub.docker.com. I will go to the directory. Now I will go to my hub.docker.com account and refresh it. So we can verify the image is being present over here. If we will go to details, then you can see a few seconds ago this image was posted, right? Now I will clear out the console, enter command docker images and remove my custom image from my local machine. So docker image rm, then the image name, hit enter. It's done. Clear out your console. Now I need to start my Python script from my image. For this, I will execute a command docker container run, then define the image name, which is Anshul DevOps slash Python program underscore program, then colon 0.0.1. So this image which we are mentioning over here is not present inside my local because we have deleted it, right? So now once I will fire this command, this will download the image from my hub.docker.com account and execute that script. Hit enter so you can see, right? So this is the way how we can create our own custom images, how we can push the images, how we can play around the images. So this is the complete solution of the assignment which we have posted in the previous lecture. Guys, if you have any question, any doubt regarding the Docker images, Docker file, then you can put your question inside the question and answer forum and I will be happy to answer. Thank you. Thanks for your time.
Hello team, welcome back. In Docker section, we have seen the networking, we have seen about the images, we have seen about the custom images, we have already discussed about the containers. And today we are going to start a new section which will be about the data management of the containers. So we will see how we can manage the data in Docker containers. So when we are learning about the Docker, when we are learning about the DevOps technologies, so the Docker container data management is an important aspect. So first we are going to discuss what are the data management aspects which are applicable in the Docker containers. What are the problems and how we can resolve these problems, right? So let's start with. So first we will learn about the container data management. Then we will see what is the persistent data and what is the issue with the persistent data. After this, we will learn about the data volumes, and in last, we will learn about the bind mount points in the containers. So these are the topics which we will discuss in very details in this particular section. So we will start with the data management or the persistent data volumes, right? So first we will try to discuss what is the data management inside the containers and what is the issue with the persistent data, right? Or what is the persistent data volumes inside the containers. So till now we have seen how we can execute the containers, right? And we have seen we can execute anything, any application inside the containers. We can execute Nginx, we can execute Tomcat, we can execute SQL, right? We can execute any application which is containerized, right? So when we was executing the container application, we have observed that containers are immutable in nature. When we have started the containers, so we was not allowed to change anything inside that particular container, right? Suppose you have started the Nginx image. Now you want to upgrade your Nginx from version 1.8 to 1.9. So it is not allowed inside the running container. So to upgrade your Nginx, first you need to stop your running container and start a new container, right? So by default, the containers are immutable in nature. Once they are deployed, they never changed, right? If you want to do something, you want to change some kind of configuration, you want to upgrade your service, then you need to redeploy that container, right? So this is the basic nature of the container. So if you want to change some kind of configuration or you want to upgrade some version inside the containers, then we have the only option, we need to redeploy the container, right? We cannot do any kind of change inside the running container, right? So this kind of approach, the immutable approach of the containers, have a lot of benefits, but it also have a lot of drawbacks as well, right? When application is running inside a container, then it may possible that particular application or particular container is producing or it is creating some kind of data, right? Then what we are doing with that particular data, where we are keeping that particular data, this is the issue, right? So by default, all files created inside the containers are stored inside the writable container layer. It means all the files or the data log, anything which is basically generated inside the containers, that is being written inside the container itself. So by this statement we can say container is immutable, right? Inside the containers our application is running, our application generates some kind of logs, our application generates some kind of data, and that data is basically writable inside the container layer, right? That is not writable inside some kind of database, that is not writable inside some kind of other third party tools, right? This is called persistent data problem. Why this is called persistent data problem? Because the data which is being written inside the containers, that data will no longer exist once you will redeploy your container, because the data which is being written by the container is persistent to that particular container. When you will restart your container, it will erase all your data and start new data generation, right? So this is called persistent data problem, and this is a very critical problem when we are learning about the auto scaling applications, right? So the data which is being generated by the containers will not persist when the container will no longer exist, right? So it will be difficult to get that data out of the container. Suppose I'm executing my database inside a container application, right? So it means whenever my container will stop, my database will be raised. But this is not an ideal scenario. So how we can deal with that particular problem, right? And what is this particular problem called, right? So this particular problem is called persistent data problem. When a particular container is generating a data, that data is basically written inside a container layer, right? This is called the persistent data, and this particular issue that data will not exist when the container will be redeployed is called persistent data problem. What are the alternative of that particular problem, how we can deal with that particular problem, we will discuss these things as well, right? So when we are dealing with the persistent data problem, Docker provides us two options, right? By this particular options, we can contain the persistent files even after the container stops, right? So the first approach is called volumes and second approach is called bind mounts. So in the coming lectures, we will discuss about the volumes and we will discuss about the bind mounts, right? But till now, we just need to understand that the persistent data problem is related to the containers when container is writing something, and that data basically need to be preserved when we are restarting or destroying the containers. And we can do this particular thing with the help of the volumes and the bind mounts, right? So team, in the next lecture, first we will learn about the volumes, then we will come up to the bind mounts. So thank you team, thanks for your time. Hello team, welcome back. In the previous lecture, we have discussed about the persistent data problem. Today we will see how we can resolve the persistent data problem with the help of the volumes. So let's start with. So first we'll try to understand the volumes and the use of the volumes. So volumes inside the containers or the Docker is basically a part of the file system where Docker will store the data, and that location will be managed by the Docker itself. A non-Docker service or non-containerized service will not manage or modify the volume parts inside the containers, right? So volumes are basically stored in a part of the host file system. So in layman terms, we can say the volumes is a directory or the part of the host file system where container will persist the data, right? Volumes are basically created and managed by the containers only, right? As we have already discussed, a non-container service will not manage and create the volumes. If user need, then user can also create the volumes with the help of the volume command. So in the same lecture, we will see how we can create the volumes if this is required, right? And when we create the volume, it is stored within the directory on the Docker host machine. So the volume is basically a directory, or you can say the file system, which will reside on your host machine. And whenever you will creating the volumes with the help of the volume command as well, that particular volume will be created on the host machine where the container is running. And as we have already discussed, that volume is the solution of the persistent data problem. So whenever you will destroy your container, volume will not be removed, right? So let's see how we can create the volume, how we can identify the volumes, and what is the use of the volumes as well, right? For this, first we will start with the container MySQL container, right? So first we'll pull the MySQL image, but before pulling the image, we will go to the hub.docker.com and go through the Docker file of the MySQL, right? So first we will go to the hub.docker.com, then we will click on sign in button and sign in on our account, right? Once you will be in, click on the search and search for the MySQL, right? So you can see we have a lot of MySQL images, and this is the official one, right? Which have 10 million plus downloads. So I will click on the official image, and over here we have different versions available. So we will click on the 8.0 Docker file version, right? And over here we can see we must have some kind of command like volume, right? Because this is the database and there should be some kind of command where we are persisting the data, right? And you can see we have the volume commands over here, right? So inside the Docker file of MySQL, it is defining the volume, and volume is being defined inside the where live MySQL. This is the location, this is the physical location on your machine where this particular container will execute, right? So first we will pull the MySQL image, right? For this we will open the terminal, and over here we will execute a command docker pull MySQL, right? So this will pull the latest image of the MySQL. So you can see it is basically downloading the MySQL image. So we have to wait until the complete image will be downloaded, and MySQL latest image is being downloaded, right? Now suppose we want to inspect the MySQL image. So we will execute a command docker inspect MySQL. Hit enter. Then you can see over here we must have some kind of command like volumes, right? You can see the volumes is being present over here, which is defining the location where live MySQL. So basically when you will start your MySQL container, it will create the data volumes or the persistent data at this particular location on your machine, right? So first let's start the MySQL container, right? So to start the MySQL container, we need to execute the command docker run -d in the detach mode hyphen name. Suppose I will name my container MySQL db. Then we need to pass the image name, which is MySQL. But we know very well that to start the MySQL, we need to pass the environment variable, right? And how we can pass the environment variable inside the containers? With the help of the -e, right? And what should be the environment variable? Environment variable would be MySQL allow empty password equals to true, right? Hit enter, and you can see the container is being started with this particular ID, right? If I will execute docker ps, then you can see a container named MySQL db is running. If I will inspect docker inspect MySQL db, then you can see it is specifying the complete details of your MySQL container, which have the volumes where live MySQL, and there should be some kind of another tag called mounts. You can see over here, right? And mounts has the destination where live MySQL, but which have the source where live Docker volumes, then some random ID, then underscore data, right? So by default, this container MySQL DB container is writing the data at this particular location. If you want, then you can go to this particular location like cd and paste it, hit enter, right? Put ls, and you can see underscore data is here. If I will go to this particular location underscore data, again put ls, then you can see over here we have some kind of files. So it means by default MySQL is running the data at this particular location, which is where live Docker volumes at, and this particular random generated ID and then particular data, right? I will go to the root, right? Again execute docker ps, right? So we can see the MySQL DB is running. Now if you want to identify that how many volumes are being created, then you can execute the command docker volume ls, and you can see a single volume with this particular random ID is being created, and this is the same ID, right? In the same way, if I will again create another MySQL container and name it MySQL db2, right? So I will execute the same command again, and I will name it MySQL db2, hit enter. Now you can see a new container is being started. If I will execute a command docker ps, then you can see two containers are running. First is MySQL db and second is MySQL db2. If I will execute a command docker volume ls, then you can see there are two volumes listed, right? It means the first volume is related to first container and second volume is related to second container, but these are the randomly generated IDs. So at runtime it would be difficult to identify that which volume is related to which container, right? Now suppose I'm going to stop my containers. So docker container stop MySQL db MySQL db2, hit enter. Then we have to wait until the both containers got stopped. I will execute a command docker ps, then you can see nothing is running. But if I will execute a command docker volume ls, then you can see that both volumes are still exist. It means the containers are being destroyed, they are being stopped, but the volume is still present. It means the persistent data volume issue is resolved, right? although my containers is being stopped, but my data is basically present, right? The data which is being generated with that particular container is not being destroyed. So this is the way how you can resolve the persistent data problem, right? Now, now suppose you want to inspect any volume, you want to inspect this particular volume, so you can execute a command docker volume inspect and then define the ID, right? So suppose I will copy this and paste it. Hit enter. So by this way you can inspect this particular volume as well, that this is being created at this particular time, created by the driver local, labels are null, mount point is this, and name is this, right? So we can inspect the volume as well. Now suppose we have a new requirement where we need to create the custom volume and we need to start the MySQL with that particular volume. So how we can do that? For this we will enter the same command, and inside this command before the image name I will define hyphen hyphen mount, then source equals, and over here I need to define my volume name. Suppose I'm defining MySQL hyphen db, then put comma, then put destination equals, and define the destination where the volume will be created. So my volume will be created inside the where lib MySQL, right? Hit enter button. Oh, I'm getting the error because there was already a running container with the MySQL db2. So I will rename my container and I will rename it MySQL db3, right? Hit enter. Then you can see a container is being started. If I will execute a command docker volume ls, then you can see a new volume is being created with the custom name which is MySQL DB, which I just defined over here, right? So with the previous approach we have the issue that we was not able to identify that which volume name was related to which container, right? But with the help of the custom volume name we would be able to identify that which volume is related to which container, right? If you will stop this container, docker container stop MySQL db3, then you can again start the same container with the same persistent volume, right? I will execute the docker volume ls, then you can see the volume is still persist. It means we can start a new container with that particular volume. It means if a container is running that has inserted some data inside your volumes and somehow you have to stop that container, and again you need to start a new container with the upgraded version, then you can start the new container with the upgraded version with the existing database, right? So with the help of the volumes we can define the volume where the persistent data will be defined, and we can start a new container with the existing data volumes, right? If you want I can show you that. I will start a new container named MySQL db4, right? And that container will be start with the MySQL DB volume. See, the container is being started. Execute docker volume ls. So although I have started a new container, but the volume is still same. A new volume is not being created, right? So I have started a new container with the existing data volume. So this is the benefit of the volumes, right? This is the benefit of the volumes, that we can start an existing container or we can start a new container with the existing volume as well, right? So this is all about the volumes. If you have any doubt, any question regarding the volumes and how we can create the volumes, how we can identify the volumes, then you can put your question inside the question and answer forum. So thank you team, thanks for your time. Hello team, welcome back. And today we are going to discuss about the second resolution of the persistent data problem, which is bind mounts. So in the previous lecture, we have discussed about the volumes, and we have seen how we can create the volume, how we can create the custom volumes, and how we can map the running containers with the existing volumes. Today we will see what is the bind mounts and how we can create the bind mounts and how we can use the bind mounts. So let's start with. So first we will try to understand the bind mounts. So team bind mounts means a file or a directory on the host machine which is mounted into a container. It means when we are saying we are using bind mounts inside the containers, then we are mounting the existing directory on the host machine with the directory which is present inside the container, right? So we are mapping the file of a host machine into a container file. So this is called bind mounts. We are mounting the container directory and the host machine directory together, right? This is quite different with the volumes. We will see what is the difference between the volumes and the bind mounts as well. Bind mounts may be stored anywhere on the host machine, right? Although the volumes also store on the host machine, right? This is the first difference between the bind mount and the host machine, that non-Docker processes on the Docker host machine can access the bind mounts and modify them. This is not possible with the volumes. If we are using the volumes, then non-Docker process cannot modify or access that particular volume inside the container. But if we are using the bind mount, we are mounting the directory on the host machine with the running directory inside the containers. Then any non-Docker process can access that particular directory and can change anything in that particular directory. But there is a benefit as well. If we are running in the development environment where we are building our project regularly, right? And we want that my container every time use some new code, right? So we can replace the jar every time inside the running container. We cannot need to start the container again and again, right? So by this way we can change anything inside the running container as well, right? So with the help of the bind mounts we can change anything inside the running container as well. But there's a limitation with the bind mount as well, like volume can be used inside the Docker file because that is not a hard code location on the because that is not a hard code location on the host machine, right? But bind mounts cannot be used inside the Docker file. You cannot define the bind mounts inside the Docker file. But if you're using the Docker file, you can use the volumes. So this is the difference between the bind mounts and the volumes. The advantage of the bind mounts over the volumes and the advantage of the volumes over the bind mounts, right? Now let's discuss some good use cases of the bind mounts as well. Sharing the configuration file from the host machine to the containers. With the help of the bind mounts, we can share the configuration files from the host machine to the containers. Suppose we have a requirement that my containers need to modify some configuration on a host machine, right? So this is possible with the help of the bind mounts. And in some case, we need to upload some new configuration inside the container. That is also possible with the help of the bind mounts, right? Sharing the source code, or you can say the build artifacts between the development environment on the Docker host and the container. So as we have discussed, suppose my container every time needs to access the new code, the changes which developer are doing, then we can mount the directory which is present on a host machine with the container, right? And container will always access that part, and container will be allowed to access any data which is present inside that particular directory. So these are some good use cases of the bind mount as well, right? Now let's start Nginx container with the bind mounts. So to start Nginx container with the bind mount, we need to use the below commands, right? We need to execute a command like docker container run -d for the detach mode, hyphen name, we can provide the container name, and then we can use hyphen mount, right? Then we need to define the type of the mount, which is bind, then comma, source equal to $pwd. It means use the current directory, right? If you don't want to use the current directory, you can define the hardcore directory over here. And then we need to define the target, right? Target means which directory inside the container will be mounted with this particular source directory, and then you can define your image name, right? So let's go to hub.container.com and verify the Docker file of the Nginx, right? So we'll go to hub.docker.com, login into account, and once you will be logging into your account, search for the Nginx. So you can see here we have the official Nginx image, right? I will click this and then I will click on the Docker file. So we will verify the Docker file of the Nginx. So over here we have the from, we have the label and environment and run command, right? Once we will scroll down, we are getting run and expose and stop signal and CMD. We are not getting any kind of bind mount or volumes, right? So how we can start the Nginx with the help of the bind mounts, right? So let's go to the terminal. So we are inside the root location, execute pwd. So we are at a root, right? Suppose I will create a directory like mkdir docker bind, right, and go to docker bind, right. So you can see if I will execute pwd, I'm inside the root and docker bind. Now suppose I want to start nginx, right, and I want to bind my current directory with the nginx working directory. So I need to execute a command docker run docker container run hyphen d hyphen name, and I will call it nginx bind, right, hyphen mount space type equals to bind comma source, then equals to dollar bracket, and inside the bracket define pwd, it means current running directory, right. Then define the target, and suppose I want to define the target like app, then you need to define the nginx, which is image name. Hit enter. Oh, there is a spelling mistake inside the target. This is target. So you can see it is downloading the nginx image, and container with this particular id is being started. If I will execute a command docker ps, then you can see the nginx is running, right, and the container name is nginx bind, right. Let me clear out my console, and I will execute docker inspect nginx bind, right. I will scroll a bit until I will find out the mount location, and you can see over here we are getting the mount location, and mount is destination is underscore app and source is root docker bind, right. So you can see if we will go to the running container, so I will execute a command docker exec hyphen it nginx bind bash, right, and I will hit enter button. So you can see I'm right now I'm so you can see right now I'm inside the running container. If I will enter ls, then over here we have the directory app. I will go to this directory cd app, right, put ls, so there is nothing, it means ls hyphen al, so there is no file, right. There is total 8 files, but all are hidden. Now I will open another terminal. So you can see right now I am working on the two terminals, this terminal where I am present inside the container, and this terminal where I am present inside my host machine. So I will clear out the console, and I will go to the directory docker bind, right, and suppose over here in this particular directory execute pwd, so I am present inside the root docker bind. This is the same directory which I have mounted inside the container and apps directory, right. Suppose I will create some file over here, so I will create a file like echo hi, this is custom file, and I will save it inside the test.txt. Hit enter, put ls, then you can see the test.txt is present inside my local file system. Now I will go to inside my containers and again put ls, then you can see the test.txt is also present over here. Earlier this file was not present over here. As soon as I have created that particular file test.txt in my local machine at a location which I have mounted with the container, so same file is present inside the container as well, right. So by this way we can see we can change anything on a host file system, and that thing will reflect inside the running container. If I will create another file like touch anshul test.txt, hit enter, and I will switch the terminal, again execute the ls-al, then you can see this file is also being created inside the running container. Over here we are present inside the container, and over here we are present inside the local file system. See, so I'm changing something inside my local file system, and that change is being reflected inside the running container, right. So this is the benefit of the bind mounts. You can change anything inside the mounted location, and that will reflect inside the running container. So you can see over here I'm able to access the bind mount location in my local file system with a non dockerized process. I'm using my terminal. This is not a Dockerized process. So non-Dockerized service can also access the bind mounts and modify the file system, right? So team, we have seen how we can use the bind mount, how we can use the bind mounts with the container, how we can mount the local file system with the running container, and how we can use them, and what are the benefits and drawback of the bind mounts, right? We have already seen the volumes in the last lecture. So this is all about the data management of the containers, right? This is the way how we can manage the persistent data of the containers in a local file system or in the volumes, right? So thank you team, thanks for your time. If you have any question regarding the volumes, data management and the bind mounts, then you can put your question inside the question and answer forum and I will be happy to answer. Thank you team, thanks for your time. Hello team, welcome back. So in this section we have learned about the data management. We have discussed about the volumes and bind mounts, right? So this is the time of the assignment. So I'm going to post an assignment for you so that you can practice the volumes in the data management, right? So let's start with. So this is the assignment for you. Over here, we need to upgrade the database with the volumes in a container, right? So what does it mean? It means we'll start a database with a specific volume, then we will downgrade that particular database, then start a new database with the existing volume, right? So here I'm listing the step-by-step task what you need to do, right? So first, you need to create a MySQL container with some specific version with a specific volume name like MySQL DB, right? You can use anything, but I will prefer to use MySQL DB as a volume name, right? Once the container will start, you need to verify that the container is started successfully, right? After then, you need to connect with your database and create some data. Create some database, create some table, insert some data in that particular table in your MySQL database. After this, stop and remove the running container of the MySQL, right? Then start a new MySQL container with the upgraded version or the downgraded version, but with the existing volume which we have used in the previous container. And after that, we need to verify that the data which we have created in the previous container is still persist in the database or not. So this is the assignment for you, right? So these are the simple steps. In the previous lecture, we have already seen how we can use the bind mounts, how we can start the containers, how we can start the MySQL containers and all, right? I know this is not a straightforward, so you can Google around the container stuff, MySQL container stuff, and you can do it, right? If you're not able to find out the answer, I will post the answer in the next lecture. Thank you, team. Thanks for your time. Hello team, welcome back. In the previous lecture, I have submitted an assignment for you. Today I am going to solve that particular assignment. So team, if you have already solved that particular assignment, then that's definitely great and you don't need to go through with this particular lecture. But if you have faced any kind of problem to solve that particular assignment, then this is the lecture for you, right? So you can get the reference from this particular lecture and you can try to resolve that particular assignment again, right? So let's start with. So in the assignment, our task was to create the MySQL container with the defined database. So in the assignment, our first task was to create the MySQL database container with the defined data volume, right? So first we will create the MySQL container, then we will create the MySQL container with the default data volume, right? So first we will create the MySQL container with the specific version with the volume named MySQL DB, right? So to get the version of MySQL, we need to go to the hub.docker.com. So we will go to hub.docker.com. Once you will land on this particular page, you need to sign in your account. I will click on sign in button so that I will log in into my account. And once you will be logged in, you need to search for the MySQL, right? MySQL, hit enter button. And very first image you will get is the MySQL official image. You can see over here we are getting the tag official image, right? So we need to click this image to verify the versions of the MySQL. So the MySQL versions are available 8.0.15, 8.0 and 8 and latest. So these are the MySQL versions which is available on the hub.docker.com, right? So we need to start the MySQL database with any of this particular version. So suppose first I will start the MySQL with the version 8.0. So first I will start the MySQL container with the command like docker container run, then provide the name of my container which should be MySQL test and define the MySQL which is your image name, right? Once you will start your MySQL with the above command, you will face some kind of issue, you will face some kind of problem, right? Because MySQL will start with some kind of password or with no password. So to resolve that particular problem, we will start the MySQL with the below listed command, right? So team, the commands which I'm going to use in this particular lecture, I have listed all these commands in this particular document, and I will attach this particular document with the lecture, so you don't need to worry about anything, right? So let's start with, let's go to the terminal and start the MySQL container, right? So we are on a terminal. So before start the MySQL container, let's execute a command docker ps-a to verify that how many containers are running or exist on my machine, right? So docker ps-a. So you can see right now MySQL container is already running, right? So to start a new MySQL container, first I will stop this running container, right? So I will execute a command docker container stop and provide the ID or the name, right? So name is MySQL db4, and suppose I'm going to stop the nginx as well. Again execute MySQL, again execute docker ps-a. Then you can see both of the containers are in the exited state, right? Suppose I will remove these as well. So docker container rm, then provide the container name, which is MySQL db and nginx, right? So both of the containers are being removed as well. If I will again execute docker ps-a, so I will not get anything. So we have already cleaned up our docker space, right? I will clear out the console. Now what I need to do, I need to start the MySQL container which have the version 8.0. For this I will execute a command docker container run, provide the name with the command name. Suppose I'm providing the name like MySQL hyphen test, then provide the image name. Image name is MySQL. Then put colon and provide the version, which version you want to use. Suppose I want to use 8.0, so I have provided 8.0 over here. Hit enter button. So first it will download the MySQL 8.0 version on your machine, right? And after the download it is showing some error, and error is database is initialized with the password option is not specified, right? So although we have seen this kind of thing in the previous lectures, but I'm showing you everything from the scratch so that you can get it better, right? So we need to specify either one of the password option. Either we need to provide the option MySQL root password, or we need to provide the option like MySQL allow empty password or MySQL random root password, right? So I will go with the first one, right? So that I would be able to know the password of my MySQL database, right? So I will execute a command docker container run hyphen name MySQL hyphen test, then define the environment variable like hyphen e and define the MySQL root password, right? So I will copy this and define it within the double quotes. MySQL root password equals to, define anything like my password. So this would be the password of my MySQL database, right? Then define the image name, which is MySQL colon 8.0. Once you will execute this particular command, this will start the container MySQL container 8.0 image with this particular password, right? So in first attempt it will fail. Let's execute and see it is failed, right? And it is saying error response from the daemon conflict the container name. So you have seen the same container name we have used earlier, and in this, and again we are using the same container name, although the container was not started, but it has created the reference entry. So first we need to remove the MySQL container MySQL test, or you can rename your container, right? So suppose I'm going to execute docker ps-a. So you can see here we have a container which is in the exited state and name is MySQL test. Now we have two options. Either we can remove this particular container or I can rename my container which I'm starting, right? So I will remove this docker container rm and provide the container name MySQL test, right? Now again I will execute the start command of my MySQL 8.0, which is docker container run name. Name would be MySQL test hyphen e, the environment variable, and in the environment variable I'm passing the variable MySQL root password, and value is my password and MySQL image 8.0, right? Hit enter. Then you can see it is printing all the logs. You can see it is initializing the database and printing all the logs. Why the logs are being printed? Why this is being printed in the attach mode? Because I have not started the MySQL container in the detach mode, so that it is being printed in the attach mode, right? And over here you can see MySQL init process done, ready to start up, right? It means the MySQL container is already being started, and it is being started on a port 3306. You can see over here, right? So this is the way how you can start the MySQL container. But this was not our task. Our task was to start the MySQL container with the defined volume or user defined volume. So first press Ctrl C to stop this particular container. So once you will press your Ctrl C, you will come out from your running container. If I will execute a command docker ps, then you can see the container is up 3 minutes ago, right? So first I need to stop this container, and then I need to start the same container with the user defined volumes, right? So I will stop the container docker container stop MySQL test, right? Once it will stop, I will remove the same container as well. Docker container remove rm MySQL container, MySQL test, right? If I will execute a command docker container ps -a, then you can see nothing is being present over here, right? So we have exited and removed the MySQL container 8.0. Now what I need to do, I need to start the MySQL container with the user defined volumes, right? So first let's go through the slides. So we have done this much of work. We have started the MySQL container, removed the existing container and start again. And we have verified that the MySQL container was running, right? Now we need to start the MySQL container with the user defined volumes. And this is the command to start the MySQL container with the user defined volumes, right? The rest of the command would be same. We will add a one more parameter --mount source equal to MySQL DB. This would be the name of the volume which is user defined, and the target, right? The MySQL DB volume will be mapped with the library inside the container which is present inside the where live MySQL, right? So let's execute this command. And once we will start the MySQL container with this particular volume, we will verify the MySQL container, right? And after that, we will go to the MySQL database and create the data. So this is the task. So let's go to the terminal. So I will execute the command docker container run --name MySQL test -e MySQL root password equal to password, then the image name. But before this, I will provide --mount, right? Source equals to MySQL DB. This would be the volume name, comma, target equals to where lib MySQL. Why I am providing this particular location where live MySQL? Because this is the volume location which is present inside the MySQL Docker file. If we will go to the hub.docker.com and I will click on the Docker file link, and we will search for the volume, then you can see here is the volume and location is where live MySQL. So I'm providing the same location in my command, right? So the complete command is like docker container run --name, then providing the name which is MySQL test -e environment variable MySQL root password, and the password would be my password, defining the volume source equal to MySQL DB. This would be the volume name, and target equals to where live MySQL 8.0, right? Hit enter button. Oh, one more thing. We need to start this container in the detach mode. So I will define -d as well, right? So I'm defining docker container run -d and name, right? Hit enter button. So you can see a container with this particular ID is being started. If I will execute a command docker ps, then you can see MySQL container name MySQL test is running, right? If we want to verify the volumes, we can execute the command docker volume ls, and we can see a new volume called mysql db is being created, right? If you want to verify, you can inspect the running container by command docker inspect mysql test, which is my container name. Hit enter. Then over here we are getting the complete details of the container, and over here we can see the volume and the mount location, right? So you can see inside the environment we are getting the password value as well, and mysql root password equals to my password, right? And here we are getting the mount locations, right? So the type is volume name is mysql db, the source location, this is the location which is present inside the running container directory, which is where live docker volumes mysql db underscore data. Where live docker volume mysql db underscore data is the location where the running container will store the data which you will create, right? If you want, then you can go to this particular location. I will copy this and go to this location, clear out the console, go to cd and paste this location which you have copied, which is where live docker volume mysql db underscore data. Then you can see this location is present. If I will put ls, then you can see we have the files present at this particular location. So it means the volume with name mysql db is successfully created, right? I will clear out the console and go to the root. So clear cd root, right? Now what I need to do, we have started the MySQL database in a container. Now we need to create a database and insert some data, right? For this, first go to the slides and go through some commands. So first we will go to the MySQL database and create the data. And for this, we need to follow these steps. First, we will inspect the container and find out the IP of the running container, right? Then we get the running port. Then we will install the MySQL client package with the command apt-get install MySQL client. And after this, we will execute the command to log in MySQL DB. And what is the command we need to execute? The command would be like mysql-u root-p. We need to define the password. Then -h. After this, we need to define the host IP. And then -p. After this, we need to define the port. The sample command is listed below in the red color, right? So this is the way how we can go inside the database on a running container, right? So let's go to the terminal and follow these steps one by one. So to find out the IP, first I will inspect the running container. So docker inspect MySQL test, and we will verify the IP and port value, right? So let's search for the IP and port value. So inside the network setting, we can get the IP, and IP is 172.17.0.2, right? And the port on which the container is started, the port is 3306. This is the default port on which the MySQL started, right? So the port is 3306 and IP is 172.17.0.2, right? Now we will try to go inside the database, right? So we will execute a command mysql -u root -p, define the password is my password, -h, define the IP which is 172.17.0.2, define -p and define the port 3306, which is the default port of MySQL. Hit enter, and you can see I'm getting the error because I have forgot to install the MySQL client package, right? So first I will install the MySQL client package, right? So I will clear out the console and execute the command apt get install MySQL client. Hit enter. Then you can see it is downloading the MySQL client. Put Y to provide the permission. It will take few seconds. So we have to wait until the client will install, and it's done. Clear out the console and execute the same command which we have executed earlier. So we will execute the same command again, mysql-u, then provide the username root, -p, then define your password. In my case, the password is my password, -h, define the IP of your host, -p, define the port. Hit enter. Then you will enter into the MySQL. You can see right now I am inside the MySQL. So I have logged in inside my MySQL database of my running container. Over here, we can do anything with the database, right? So suppose I'm going to create some data, right? So I have listed down all the commands on the slides. So you can go through the slides first. So first we will create a database with the command like create database and provide the database name. Then we'll create the table in the database, and table name could be persons, right? Which have the 4 columns like person ID, last name, first name, address, and the city. And after this we will insert the data in this particular table, right? So we will insert 2 rows in this particular table, and after this we will verify the database person table, right? So these are the commands we need to execute on this particular database, right? So first we will create the database with the command create database and database name, suppose test db, right? Hit enter. So you can see queries okay, 1 row affected. If you want, you can show the databases like command show databases. Then you can see over here we are getting all the database which is present inside the MySQL DB, and our newly created database is also present over here, which is test DB, right? Now to insert the data inside my test DB, I need to switch to the test DB first. So I will use the command use, then provide the DB name, which is test DB, right? Semicolon, hit enter. Now you can see we got the message database changed. Right now I'm using the database test DB, right? Now to create the table, I need to insert the create table command inside my MySQL, right? Now what we will do, we'll insert the create table command on the terminal inside my MySQL DB and hit enter button, right? Then you can see query OK, 0 row affected. It means the table is being created. If we will execute a command show tables, then we can see a new table named person is being created over here, right? Now our task is to insert some data in this particular table, right? So we will copy the insert into commands on my terminal. So by this query, we are inserting the data into a person table, right? So we have inserted a query like insert into persons, the column names like person ID, last name, first name, address, and city. And then we have defined the value of these particular columns. Hit enter button. Then you can see query OK, 1 row affected, right? Now we'll insert some more data into this particular table. So we have inserting the second row, the value is 17, Michael Martin, Keskikatu, Finland, right? Hit enter, then query is affected. Now we will commit our data. Now we need to verify that the particular data is successfully inserted or not, right? So we need to insert a query like select asterisk from persons, put semicolon, hit enter. Then you can see we have the 2 rows in the person table, the first where the id is 14 and second the where the id is 17. So the first last name is Birkson and second is Martin. First is from the Norway and second is from the Finland, right? So we have inserted the data inside the MySQL DB, and which MySQL DB is running inside the container, right? Now what we need to do, we need to exit out from the MySQL. So we will type exit semicolon, hit enter. So we are out from the MySQL DB, right? Now clear out your console. If you want to verify, you can execute a command docker ps, then you can see MySQL container is running, right? Now what I need to do, I need to stop this container, remove this container, start a new container with the upgraded version with the same volume, right? So we need to follow these steps. First, we will stop and remove the running container of the MySQL. Then we will start a new MySQL container with the earlier data volume which we have created in the current container, right? And then we will go to the database and verify that the particular data which we have created in this particular container will exist or not, right? So let's go to the terminal. To stop the container, I will execute docker container stop MySQL test, execute a command docker ps. Then you can see nothing is being coming. It means the container is being stopped, right? Now I will remove this container. So docker container rm MySQL test, execute a command docker ps -a, then you can see nothing is being present. It means the container is stopped and removed, right? So ideally, if the volume concept is not present, then the data which we have created with the container should be erased, right? But we have created that particular, but we have started that particular container with the custom volume, right? So the data should be persist inside the volume. Either we will start a new container with the same existing data volume. So we will start a new container of the MySQL, right? And we will start a container MySQL 8.0.15, right? The upgraded version of the MySQL. And I will name it anything else. If you want, you can keep it same name like MySQL test, or you can change it, right? So what I'm doing, I'm starting the MySQL upgraded version with the existing data volume MySQL DB. See, I'm using the existing data volume MySQL DB over here, right? Which we have used in the previous MySQL container. Hit enter. Then you can see a container with this particular ID is being started. If I will put Docker PS, then a container is running, right? So first I need to do, I need to find out the container IP. So Docker inspect MySQL test, right? The IP is same 172.17.0.2, right? And the port is 3306, right? Now what I need to do to verify the data, I need to log in into my MySQL container, right? So I will execute the same command MySQL -u root -p, then define your password -h, define the host IP -p, then the port. Then hit enter button and you can see we have inserted inside the MySQL DB, right? So first we will verify how many databases are being present over here. So I will execute a command show databases, semicolon, hit enter. Then see, test DB is being present over here. So why the test DB is present over here, although we have not created the test DB in this particular container? Because we are using the existing data volume with the new container, right? We have upgraded the MySQL, but we are using the same database which we have used in the previous container. So team, this is the resolution of the persistent data problem. We have stopped and removed the earlier container, but the data which we have created with the previous container is still persist, and we can use that particular data with the new containers, right? So by this way you can scale up your application with the existing data. You can scale up your Docker with the existing data. If you will use this particular database, use testdb, execute a command, select asterisk from person, then you can see the data which we have created is also present, right? So this is the way how the data volumes are resolving the issue of the persistent data. We can contain, secure the data at a single place and scale up our container application again and again, right? So this is the complete solution of the assignment which I posted in the earlier lecture, right? If you have any doubt, any question regarding this particular tutorial, then you can put your question in the question and answer forum. Also, I have listed all the commands which we have used in this particular lecture in the document, and I will attach this particular document with this particular lecture. So thank you team, thanks for your time. Hello team, welcome back. As we have already discussed about the bind mounts, so today I'm going to post an assignment on the bind mounts. So team, I'm expecting you will resolve this particular assignment without any help. So let's start with. So in this particular assignment, we are going to start an Nginx container, and we are going to start that Nginx container with the bind mounts, right? When we are creating the bind mounts, we'll edit the index.html file in the local system or the mounted location on the host machine. And we will see is that the same file changing on the running container or not, right? So this is the simple and shortest assignment on the bind mounts which you need to solve by yourself, right? If you're not able to solve this particular assignment, then in the coming lecture you can find out the answer. So thank you team, thanks for your time. Hello team, welcome back. And in the previous lecture I have posted an assignment on the bind mount, and in this lecture we are going to resolve that particular assignment, right? So assignment was we need to start the nginx with the bind mount location, and we need to verify that if we are changing the index.html file or we are creating the new files at the mounted location, that the same thing is being reflected inside the running container or not, right? So let's start with. So first we will start an nginx with the mounted location, right? Then we will see how we can change the files on the mounted location, and we will verify that the same file is being changing on the running container or not, right? So let's go to the terminal. So we are on the terminal. First here we will verify is there any container running or not, right? So we will execute docker ps -a. Then we can see an nginx container is running since last 28 minutes, and nginx container is exited state 29 minutes ago. What I will do, I will stop the container, right? If you want, then you can remove the containers as well. So docker container rm, provide the id which is 456 and 11a. Execute a command docker ps-a. Then you can say nothing is being present on my docker space, right? I will clear out my console. Now what we will do, first, we will identify the IP of my machine because I'm running the Docker on a cloud machine, so I cannot access the container on the local host, right? So I'll put if config, right? And over here we are getting the IP is 134.209.5.248. This is the IP of my machine. I will save this IP at some location, right? Now what I will do, I will start the nginx container. For this, we will execute a command docker container run -d -name nginx test -p, expose the port 80, then image name which is nginx, right? So we can see a container is being started. If I will execute a command docker ps, then you can see a container is started 7 seconds ago, right? Now what I need to do, if we will go to this particular IP, right, copy this IP, go to the browser, paste this IP, put :80, put slash and type index.html. Hit enter. Then you can see it is landing you on a particular page. Welcome to nginx, right? So this is the default nginx page. If the nginx is running, then you will land on this particular web page, right? If you will stop the container like docker container stop and the container name which is nginx test, and I will refresh my browser, refresh your browser, then you can see this page is not accessible, right? If I will again start my container docker container start nginx test and refresh my web page, then you can see page is again accessible. It means this page is accessible once the container is running, and page is not accessible, the container is not running. It means this file, the index.html file, is present inside the running container. So we need to find out the location of this index.html file, right? So we will go to the terminal, clear out the console, and we will go to the running containers. So docker exec -it, define the container name bash. So we have inserted inside the running container. Over here we will go to the directory user share nginx html, right? So this is the location user share nginx html inside your running container, where all these files are present, the index.html file and 15x.html file. If we will access this particular file 15x.html, paste it over here, then you can see this file have some error content and error occurred and all, right? If you want, you can verify the content of these files as well on your terminal. See, this is the content of this particular file 15x.html and cat index.html. This is the content of index.html file, right? Clear out your console, exit out your container, exit, then put docker ps and container is running. Now stop your container, docker stop nginx, right? Now we will remove the container, docker container rm nginx test. So we have stopped the container and we have removed the container. Now what we need to do, we need to start the nginx container with the mounted location with bind mounts. So first I will create a directory mkdir test nginx. Now I will go to this particular directory test nginx, right? Exit, enter command pwd. So my current working directory is test nginx. What I'm going to do, I'm going to mount this particular directory test nginx with the user share nginx html directory inside my running container, right? For this we need to start a command docker container run -d -name, provide the container name nginx -bind. I'm providing this custom name like bind. Then provide -p port 8080. Then we need to define the mount location, right? So -mount type equals to bind comma source equals to double quotes dollar bracket pwd, which means the current working directory, right? Put comma, then target equals to what is the location we want to mount. We want to mount this location where the all files are present. So I will copy this location and paste it inside the target, right? Remove these double slash. Now provide the image name, which is nginx. Hit enter. So you can see the container is being started, right? If I will put ls over here, then in this particular directory test nginx directory nothing is present, right? Now I will open another terminal, and inside this terminal I will execute a command docker ps, right? So we can see nginx bind is running, nginx container name nginx bind is running. So what I will do, I will go inside this particular container. So docker exec -it nginx bind bash, right? Now I will go to the location user share nginx html. I will put ls. Then you can see inside this directory nothing is present, right? So when we was running the nginx container, there was two files present at this particular location user share nginx html. But as soon as I have mounted this particular location with my local file system, which is present over here and which is blank, so this location is also being blanked, right? Now if I will go to the browser and refresh this particular page, then nothing should be appear. See, we are getting 404, nothing is being appeared. Nginx is running, but there is no file present, right? Nginx running, but there is no file present. Now if we will again go to the terminal, right, and this is my local file system, and over here suppose I will create a new file touch test index.html, right? Put ls. See, test index.html is present on my local file system, right? Now this is the location where I'm working inside the running container. I will put ls, then same file is being created over here as well, right? Now suppose we will insert some data in this particular file. So we will open the file in a vi mode, right? Press I to insert and create some data over here. So I have inserted some data, the HTML data. The title is sample nginx file. Then we have a heading my nginx file. Then some paragraph. See, I am using bind mount running container. I will put escape colon wq to save this particular file, right? Press ls, then you can see the file is present over here. And if you will go to the container and press ls, the file is present over here as well. Now we will go to the browser, and inside the browser I will put slash and type my file name, which is test index.html. Hit enter. Then you can see we are able to access that particular file inside the running container, right? So this is the benefit of the bind mounts. With the help of the bind mounts, you can change anything inside the running container. You can change your development code inside the running container, right? And you can always start or execute your container with the updated data or updated code, right? So this is the answer of the assignment which we have posted in the last lecture. If you have any question, any doubt regarding the data management, bind mounts, volumes, then you can put your question inside the question and answer forum. So thank you, team. Thanks for your time. After this particular lecture, I'm going to close this particular section. In the coming section, we will learn about the Docker Compose. So thank you, team. Thanks for your time. Hello team, welcome back. And today we are starting a new section. And in this particular section, we will learn about the Docker Compose, right? So let's start with. So first, we will try to understand the Docker Compose. So Docker Compose is basically used to execute multiple containers as a single service. So in some previous lectures, we have seen we have to execute the nginx, we have to execute the Tomcat, the MySQL, PHP server, and some other application, right? What if I need to execute multiple containers in a single service? So what is the solution for that particular thing? So Docker Compose is the solution if you want to establish the relationship between the multiple containers, right? So with the help of Docker Compose, you can start and you can use the multiple containers as a single service. So for example, if user want to start the MySQL with the Tomcat container, then user need to create the one YAML file, right? And Docker Compose will use this particular YAML file to start both of the container as a single service. So Docker Compose is basically divided in two parts. The first part is the YAML file, which is the configuration file for the Docker Compose, and second part is Docker Compose CLI, right? So Docker Compose command line and Docker Compose YAML file is the combination which will be used to start the multiple containers as a single service. So Docker Compose is basically a three-step process. In the first step, user need to define the application environment with the Docker file so that it can be executable or reproducible anywhere, right? In the second step, user need to define the services, the containers, and make an simple Docker Compose YAML file. And with the help of this particular Docker Compose YAML file, you can execute your container in isolation together. And third, you just need to start the Docker Compose YAML file with the help of a command Docker Compose up on the Docker CLI. So this is a three-step process. When you want to execute the containers with the help of a Docker Compose, we need to follow these steps. Now let's discuss how we can install the Docker Compose. So the prerequisite to install the Docker Compose, Docker should be installed on your machine, right? So the very first, we need to download the necessary files of the Docker Compose from the GitHub. You can use this particular command to download all the things which is related to the Docker Compose. So right here you can see we are using version 1.23.2 of the Docker Compose. So this will download all of your Docker Compose file inside the user local bin Docker Compose directory, right? After this, we need to provide the executable permission to the binary files which we have downloaded inside the user local bin and Docker Compose. So we need to execute this particular command. And after this, we just need to verify the Docker Compose version with the help of a command Docker Compose version, right? So let's see how we can install it. So I'm on my terminal, and if I will enter a command Docker version, so you can see Docker 18.09 version is running on my machine. So we have already done the prerequisite. Docker is already running on my machine. Now I need to insert a command to download the Docker Compose files. So I will paste my command over here. So once you paste, you can see it has downloaded all the files in this particular directory, right? Which is user local bin Docker Compose. If you want, you can change this particular directory, but I would like to prefer this directory as this is the default directory defined by the Docker for the Docker Compose. Now, if you want, you can cd to this particular directory, user local bin, hit enter, put ls, and you can see Docker Compose and Docker machine are already here, right? This Docker Compose have some binary files, right? So we will again go back to the root, clear out the console. Now in the second command, we need to provide the permission to this particular file location, right? So with my second command, I will provide the permission to the Docker Compose binary. So I have already provided the executable permission to the Docker Compose binary. Now what I need to do, I just need to execute Docker Compose. This is the Docker Compose command line command to execute any Docker Compose command, right? If you want to verify the version, then type double dash version. So you can see Docker Compose version 1.23.2 is installed on my machine. right? And this is the build number. So this is the way how you can install the Docker Compose on your machine, right? In the coming lecture, we will learn about the Docker Compose YAML file. Thank you, team. Thanks for your time. Hello, team. Welcome back. Let's discuss about the Docker Compose YAML file. So we will see how we can create the YAML file, what is the YAML file, and how significant the YAML file for the Docker Compose. So let's start with. So Docker Compose YAML file is basically a formatted file for the Docker Compose, which describes the solution for containers, that how many containers needs to be run in this particular Docker Compose as a single service. It will also supports the networks. You can define your own network. You can define your network configuration and network setting for the Docker containers. And you can define your volumes, right? So we have discussed about the containers, networks, and volume. Docker Compose YAML file is the combination of the containers, services, networks, and volumes, right? So we will see how we can create the YAML file, and with the help of the YAML file, how we can start the containers as a single service. But before this, first we will discuss about the component level of the Docker YAML file, right? And the first thing about the Docker YAML file is YAML file can be versioned, right? It could be version 1, version 2, and version 3. Today we are using YAML version 3. So in the very first line of your YAML file, you need to define the version of your YAML file, right? Now, YAML file can be used with the Docker Compose command. If you want to execute your Docker Compose YAML file, then you must need to use the Docker Compose command. And default name of the YAML file in the Docker Compose is Docker Compose YAML, right? If you are providing your custom name, then you can execute your Docker Compose file with the command like docker compose -f, then provide your YAML file name. So let's go to the editor and try to understand the component level of the YAML file. So team, over here I have generated a sample YAML file which is template.yaml, and in this particular template file I have defined different labels. So the very first label is about the version, and we need to define the version. The current version of the YAML which is running is version 3, right? And this version is specific to the compose file syntax version, right? Now after the version, we need to define the services tag. Inside this services tag, we need to define the different services, and these are the services which are basically the containers in the production, right? The container name which you want to execute, right? For that container, if you want to specify a particular image, then you can define the image. If you want to execute a particular command inside that particular container, then you can define the command over here. And this command which will specify over here, this could be the shell or anything, and this command basically will replace the command cmd which is present inside the Docker file of that container. After then, if you want to define the environment variables for your container, then you can define with the help of the environment tag, and you can define the volumes for your container with the help of the volume tags as well, right? And again, you can define your another container, right? And specify the image, commands, volumes, and anything whatever you want. You can also define the volume at a compose level, right? This is optional, and this is a mounted link path of your host machine to the containers. And in the similar way, we have discussed about the networks in a Docker. You can define the different kind of networks over here. So this is the template of your Docker compose file. In the coming lecture, we will see how we can execute the multiple containers with the help of a Docker compose file, right? So if you have any question, any doubt, then you can put your question in the question and answer form, right? So thank you, team. Thanks for your time. Hello, team. Welcome back. And today we will see how we can execute the containers with the help of Docker compose, right? So let's start with. So in this lecture, we will see how we can start the MySQL and WordPress containers with the help of Docker compose. So team, we are not going to create the Docker file, right? We'll start directly from the Docker Compose YAML file. So first, we will create the Docker Compose YAML file with the default name, right? So, so I will show you the implementation of the Docker Compose YAML file, right? And I will explain each and every step, but I will mention over there. Once we will prepare the Docker Compose YAML file, we will save the file and run the file by a command docker compose up -d, right? So Docker Compose is the CLI command to start the Docker Compose up is used to start the Docker Compose YAML file, and -d to start the Docker Compose YAML in the detach mode, right? If you will not use the -d, then it will start your YAML file and start the containers on the attach mode on your terminal, right? Once the container will started, we will verify the containers on a host machine, right? After this, we will try to access the WordPress on a browser, and in last, we will down the Docker containers by Docker Compose, and command would be Docker Compose down. So this is the exercise we are going to execute in this particular lecture. So first, let's see how we can create the Docker Compose YAML file. For this, I will go to the Visual Studio Code Editor, or you can go to any code editor which is available on your machine, right? And over here, I will create a new file and call it docker-compose.yaml. In this YAML file, first I will define the version colon single quotes 3, right? So this is the version of YAML file. To put the comment, you can put use hash, and I will call it version of YAML file, right? After this, we will define services. We have seen the file template in the last lecture, right? And inside the service, I will define my first service. So suppose I will name my service like DB, then put colon. After this, I need to define the image, right? So I will use MySQL 5.7, right? This is your image name and this is your image version. So I'm using MySQL 5.7. After this, I will define the volumes for the MySQL image, which could be defined like dash your volume name. So I will name it db underscore data colon where lib MySQL. We have already discussed about the MySQL volumes in the volumes lectures, right? Now I will define another parameter restart, and I will keep the value always, right? So what restart will done? So first, I'm basically preparing this particular Docker YAML file. I will explain the use of each and every command or each and every line which I have mentioned over here, right? After the restart, to define the environment variables, I will define environment, right? And I will define the environment variables like password, username, and all. So you can see I have defined 4 environment variables. The first is MySQL root password, the value is my password. Then I have defined the database name MySQL underscore database, and the value is WordPress. Then I have defined the MySQL user with the help of MySQL underscore user variable, and the value is WordPress user. Then I have the MySQL underscore password. This is the password of the database, which is WordPress, right? So these are the environment variables which I have defined for my service DB. So you can see. So now let's understand this Docker file. So first I have defined the version, right? Then I have started the services, and the first service name I have defined is the DB, right? Inside this service, I defined the image, and image is MySQL 5.7 version. Then I defined the volumes, and inside the volumes, I have mounted where live MySQL with the DB underscore data. Then this is something new we have not discussed in the previous lecture. Restart always. It means restart my container whenever the host machine will take the restart, right? It will also restart your container whenever the container will crash. It will also restart your container whenever your container will be hanged, right? If anything wrong goes with your container, then it will restart your container, right? And with the help of the environment, I have defined the environment variables, right? Root password, database, username, password, and all, right? Now let's define the another service. So suppose I'm going to define the another service WordPress, right? Now after the WordPress, I will define another parameter depend on, and I will make it depend on hyphen db. Db is my MySQL DB service. So what I'm doing over here, I am making the WordPress container depend on the DB container, which is my MySQL DB container, right? Then I will define image. Image is WordPress, suppose latest. Then I define ports, right? So suppose I want to expose my WordPress container on port 8080. So I will define 8080 colon 80, right? Then I will define restart colon always. Then I will define environment, right? And inside the environment, I will define few environment variables like WordPress DB host. So DB host is DB, right? This is the service and which will accessible over the port 3306. Why 3306? Because my SQL container starts on a port 3306, right? After this, I have defined the WordPress DB user. So this is the same DB user which we have used over here, right? Then we need to define the DB password, right? So password would be the password we have used over here. And after this, we need to go to the main file and define the volumes. And volumes is DB underscore data, right? This is the volume we have defined, right? You can see we have defined DB underscore data over here. So this is my file. I will save this particular file, right? So this is my Docker Compose YAML file, which we have created to start the container MySQL and WordPress together, right? Now what I will do, I will go to the terminal and over here I will create a YAML file. So touch Docker Compose .yaml, put ls. So you can see Docker Compose YAML file is being created over here. I will provide the executable permission to this particular file. So chmod 777 Docker Compose YAML, put ls hyphen lrt. So you can see this file have all the permissions, right? Now clear out your console and open the Docker Compose file in a vi mode. Press I button to go inside the insert mode. Copy the complete data which we have generated on the Docker Compose YAML and paste it over here, right? Press escape colon wq, enter, right? If you want to see the content of the Docker YAML file, you can use cat Docker Compose YAML and you can see this is the content of the Docker Compose YAML file. The same content we have generated on my Visual Studio Code. This is the one way. Another way is you can directly upload this particular file on your machine where you are executing your Docker, right? If you are executing your Docker on your local machine, then you can simply use this particular file, right? You need to go to this particular location where you have saved your docker.yaml file and execute the command docker composer up -d, right? That's all. Because we are using the Docker on a cloud machine, so I have uploaded the file over here. Now I will execute a command docker dash compose up -d, hit enter. So you have to wait. So team, we are getting an error and error is docker compose YAML is invalid because top level entry repository service. Okay, there's a mistake. Instead of the service, this should be services. So these are the mistakes sometimes we did because there's a lot of things to remember, right? So this tag should be services. So I will keep it services, right? Go to insert mode by pressing the I key on keyboard and insert the services instead of the service. Now press escape colon wq and hit enter. Again execute the same command. Now again execute the same command docker compose up -d. So now we will clear out the console and again execute the docker compose up -d. Hit enter. So you can see it is starting the containers. So first it will download the container MySQL container 5.7, then it is downloading the WordPress. So once the download will complete, it will start the container, right? So we have to wait until the complete process will be done. And you can see at end we are getting creating root db-1 done, root WordPress done, right? Now if you will clear out your console and you will execute a command docker ps to verify that the containers are running or not, then you can see three containers are running. You can see WordPress latest and MySQL 5.7 are running, right? So this is the way how we can basically start the containers with the help of Docker Compose, right? The main thing about the Docker Compose is the Docker Compose YAML file. If we will again go to the Docker compose YAML file content. Then you can see this is the content of the Docker compose YAML file, over where we are executing two containers, the MySQL and the WordPress. Now to verify the WordPress, go to the browser. So team, if you are using the Docker on your local machine, then you need to put the local host like this, colon 8080 slash WordPress, and hit enter button. WordPress default page should open on your machine, right? But as we are using the cloud machine, so instead of the local host, we need to put the IP of my machine, right? If you are using the cloud machine, then you need to put your IP over here. So this is the IP of my machine. Why I'm putting port 8080? Because this is the port I have exposed inside my Docker YAML file. Hit enter. Then you can see it will open the WordPress initial page, right? If you want, you can go with this particular page. Suppose I will go with the English and continue, right? Over here, if you want, you can fill out this particular form, right? So suppose I'm going to fill out the site title like devopscycle.com. Username is devops, right? Password, suppose I will keep this password and copy it in my notepad plus plus. Now email, I will put my email and install WordPress. So what this will do, this will install the WordPress on your machine. So you can see username is this, password is being chosen. I will go to login, enter my username and password, hit on login button. Then you can see right now I'm inside my WordPress setup, right? Over here I can do anything. So I'm executing the WordPress in my container. If I will go to the terminal and execute docker ps and execute a command docker WordPress latest, or put the id of the docker, this container, the WordPress container, or put the id of the WordPress container and type log. If I will go to the terminal and type docker ps, and suppose I will type a command docker log hyphen t, and then put the id of my WordPress container, right? Hit enter. Suppose I will put a command docker ps to identify all the containers, and I will execute a command docker log, then my WordPress container id. Control C, Control V, hit enter. Uh, the command should be docker container log. If I will execute a command docker ps, then you can see all the containers are running. Suppose I want to see the logs of my WordPress container. So I will execute the command docker container logs, then the container ID. So I will put the container ID over here, hit enter. So you can see over here I'm getting all the logs of the container. If I want to execute the logs, if I want to execute the log in the running mode, then I can use like docker container logs hyphen hyphen tail, then the container ID. Then I can use the command like docker container logs hyphen f, then container ID. Now see, if I will put this some space in my log, right, and go to the browser, and suppose I will minimize my browser to show you something, right? So I will keep. So now suppose if I will refresh this and go to the terminal, then log will refresh over here. See, right? If I will perform some operation over here like updates and go to the terminal, then logs are being generated over here. So by this we can see the WordPress application, the complete application is running inside the container, right? So this is the beauty of the container applications, right? So team, we have seen how we can execute the multiple containers as a service with the help of the Docker Compose, right? If you have any question, any doubt regarding this lecture, then please put your question in the question and answer forum, and I will be happy to answer. So thank you, team. Thanks for your time. Hello, team. Welcome back. Welcome to the Docker training. And today we will see how we can create and Docker Compose YAML file, and we can build an application from the scratch. So to create the Docker Compose YAML file And to create the YAML file from scratch, we will go to our editor, right? So right here we are on our editor, right? Over here I will create a new file and I will call it custom application.yaml, right? Hit enter. Now here we will start to create the file from my scratch. So first we will define the version, and version could be 3, right? After the version we will start defining the services. So I will define services, right? Then I will define my first service. So suppose as a first service I need to define some Linux distro. So I will call it distro, right? Then I need to define image, and I will define the image Alpine, right? So Alpine is the shortest image of the Linux. And if I'm not defining anything after the image, then it will download the latest image of the Alpine, right? Then I will define the restart, and I will define always. Then I will define container name, container underscore name, and suppose I'm defining custom Alpine. Then I will define some entry point, right? And I'm defining something like tail hyphen f dev null. Now let's try to understand all the commands which we have mentioned in this particular YAML file, right? So my first command is the services, right? So every service which is present inside the services will start a new container when you will start Docker Compose up, right? So I will define the same line in a comment, right? So I have defined each entry in the services section will create the separate container when the Docker Compose is run, right? So my first service is distro, right? This is my image name. So image would be download at runtime, right? Now restart always. What is this? So as we have discussed in the previous lecture, if the host machine will restart, then the container will restart itself again, right? If the container is stopped due to some kind of corruption, then it will restart itself. If the container goes down due to any kind of reason, then it will restart itself, right? So this is the benefit of restart always. So I will define like this, like directive is used to indicate that the container should always restart, right? Now in the next line, we have defined the container underscore name. So if you are defining this particular thing, container underscore name, then this will replace the randomly generated container name inside the Docker with this particular given name, right? So I will define the complete command here, like directive is used to override the randomly generated container name and replace it with the name that is easier to remember and work with, right? Now next is entry point. So this is again the new thing which we have not seen in the previous lecture. So first let's understand why we are defining entry point like tail hyphen f dev null. So we are defining this command due to the functionality of the container. So if nothing is running inside the container, then container will exit itself, right? So we are defining tail hyphen f. This is an ongoing command, so this will not stop and container will not stop, right? So I will define the comment over here, like, so the comment is tail hyphen f is ongoing process, so it will run indefinitely and prevent the container from stopping, right? So default entry point is overridden to keep the container running. So this is my first part. So this is the first part of my custom application.yaml file, right? I will save my file, right? Now we will go to the terminal, and inside the terminal I will execute a command docker ps to identify that how many containers are running. So right now only one container is running, which is nginx. I will stop this container, docker container stop, right, and provide the container name which is nginx bind, right? Again execute the docker ps and you can see nothing is running, right? I will clear out my console. Over here I will create the file touch custom application.yaml. Hit enter. Now if you will put ls-lrt, then you can see this file only have the read and write permission, right? this don't have the executable permission. So first I will provide the executable permission to this file, which is chmod 777, the file name, right? Hit enter. Again put ls-lrt. Then you can see this file have the executable permission as well, right? Now I will open the file in the vi mode. So custom application YAML, right? Press I to come into the insert mode. Go to the file which we have created, copy this file and paste it here. Now I will press the escape key colon WQ. If you want to show the content of the file, then you can use custom cat, then file name, and you can see it is displaying the content of the file, right? Clear out your console. So team, if you have the same question again, that why we are copy the file in the terminal, because we are executing the Docker on a cloud machine, right? This is a cloud machine, this is not my local machine terminal, right? And I have created the file, the YAML file in my local machine, so that I copy the content from my local to my cloud machine. If you are executing the Docker in your local machine, then definitely you can execute that particular file directly. You just need to go to that particular directory where you have created that file in a terminal, right? And execute the command docker compose up, right? Now you need to execute the command docker compose -f, define the file name, which is custom application YAML up -d. Hit enter. Then you can see it is downloading the Alpine, and you can see creating custom Alpine done. If you will put docker ps, then you can see a new container of Alpine is running and name is custom Alpine, which was given inside the custom application.yaml file. So this is the command docker compose -f, then your file name up -d to start the YAML file if the default name not is docker compose.yaml, right? If you have your own custom name, then you can start your YAML file by this particular command, right? Now let's stop this particular container. So we need to execute a command docker compose -f, then your file name, then down. Why we are executing -f and file name? Because we are executing the docker compose with a custom file, right? Hit enter. So it will stop your container. So you can see it is printing the message stopping custom Alpine, right? So it will take few seconds to stop your container and display the success message. See, the container is being stopped. If you will press docker ps, then nothing is running, right? Now let's go to the YAML file again and add some more distro over there. Now let's go to the YAML file again and add some more services over there, right? Now we will add some more services. So we have added one service. Now we are going to add another service. Suppose the next service which we want to add is a database, and in the last lecture we have added the database MySQL. Suppose this time we are adding a database of Postgres. So I will add another service like database. So when I'm defining another service, basically it means it's a new container for my Docker Compose, right? So this is the first container distro and database is the second container, right? Over here, first I will define the image, and I will define the image Postgres latest. Then suppose I'm defining the container name, and I will define it Postgres underscore DB. So we have already discussed about the property of the container name, right? And next we are defining the ports, and suppose the port is 5432 colon 5432. Why? Because Postgres by default start on the port 5432, right? And in the similar way, suppose you want to define the volumes as well. So we are defining the volumes like dash dump colon temp, like this, right? So we have defined the another container which is database, right? And database of the Postgres, right? Now suppose I will copy this file again, go to my terminal, open the custom application YAML file, right? Remove the old content, go to the insert mode and paste this particular file. So in this particular file, we have added another container which is database, right? Press escape colon WQ to save my file. If you want to see the content, you can use cat, then your file name, hit enter. Then you can see it is defining the both of my containers, right? See, clear out my console. Now I need to define the same command again. Docker compose -f, your file name, up, then -d. Hit enter. So first it will start the Alpine, right? And next it will start the Postgres. So you can see it is downloading the Postgres, right? And all done. If you will put the command docker ps, then you can see two containers are running. The one is Postgres DB and first is custom Alpine. See, right? The two containers are running, right? And over here you can see the port as well. We have defined this particular port, right? So this is the second container we have mentioned inside my Docker YAML file. Suppose I again need to stop the container, so we'll execute a command docker compose -f, then your file name, then down, right? It will stop both of my containers. So you can see it is stopping the container, and once done, it will exit out. So you can see the both of the container is being stopped, right? Now let's again go back to the YAML file and add another container in it. So we will add another container over here, and suppose we are adding the nginx container and we will name it web, right? Image nginx. If we are not defining anything, then it will take the custom image, restart, true, always. Oh, we forgot to define the restart over here. It's good practice to define the restart in your compose file, right? In the similar way, I will define the container name, right? So we will define it nginx underscore web. Then suppose you know to define the ports, you can define the ports as well. And we are defining the port 8080 and listening the TCP port 80. So we have defined the image, we have defined the restart, container name and ports. Suppose we are defining the volumes as well, and we are defining the volume like my site template, and etc nginx config my site template will be append to this particular my site template, right? Then again we need to define the environment variable, and suppose first I'm defining the nginx host, and we are defining nginx host sample.com. Next we are defining the nginx TCP port which is 80, right? Now I will define the links with my previous containers. So first container is the database, right? So I will call database DB, and second as the distro, right? Now let's discuss all the commands we have mentioned over here. So we are aware of the image, we are aware of the restart, container name, ports, volumes, environment. This is new. So what does it means by the links? So with the help of the links, I'm linking my nginx container with the database Postgres container and the distro, which is Alpine. So if Alpine or database will take the restart, nginx will again take the restart, right? So this is the benefit of the links. We are making the containers like a fail safe. If any one of the like if any of the container like distro database will take the restart, then this container will also take the restart. And then we are defining the database colon db. So over here with this particular colon, we are basically creating the alias of this database container, right? If we will ping the db from my nginx container, then it will reach out to the database, right? So this is just an alias. If you want, you can remove it as well. So by this way we have created three containers, right? The first is Alpine, second is the Postgres, and third is the web. But till now we have not defined the database persistent data into a external volume. See, still we are not defining the database persistent data into the external volumes. So we need to define the volumes, and inside the volume, suppose I'm creating the volume, the name is data, and I will call it external, and suppose the value could be true. So what does it mean? External true is telling Docker Compose to use the pre-existing external data volume, right? That's it. Now if you will run this particular YAML file, right, and if this particular data is not already present, then this will show you the error, right? So let's copy this complete file, go to your terminal, clear out your terminal and open the custom file again in the vi mode. Remove the existing content from it, press I and press Ctrl V to paste your data over here, right? Now press escape colon WQ, right? If you want, you can get the data with the help of command cat, then your file name, and you can see it is printing the complete file data. See, right? I will clear out my console. If I will execute a command docker volume ls, then you can see we have the volumes like this random volume, this another random volume, mysql db and root db data. We don't have the volume named data, right? If I will start my docker compose -f custom file name, then up, then -d, hit enter. So we are getting the error, right? So as I told you, if the volume is not there, then you will get the error. So first we need to create the volume, right? So it is, the error is creating network data root default with the default driver. Error, the volume data declared as external but could not be found. Please create the volume manually. Docker volume create name equals to data. I simply copy this command, paste it here, right? Execute the command docker volume ls. And you can see a new volume named data is being created. If I will start my docker compose now, then I would be able to start my docker compose. See, all set. If you will execute the docker ps, then you are able to access it, right? See, so this is the way how we can create the docker containers ecosystem with the help of the docker compose. Team, if you have any doubt, you have any question regarding this particular tutorial, then please put your question in the question and answer forum and I will answer your questions, right? So thank you team, thanks for your time. This is the last lecture of the docker compose. There is not so much to discuss about the docker compose. Docker compose is just to create the ecosystem of the multi containers, and we have seen all the things about that particular thing. If you still do you have any question, you have anything, any concern, right, then you can write me. So thank you team, thanks for your time. Hello team, welcome back. And today we will start a new section. In this particular section onward, we will learn about the Docker Swarm. So till now we have discussed about the containers, images, Docker. From this section onward, we will learn about the Docker Swarm, right? So we will see what is Docker Swarm, we will see what is the application of the Docker Swarm and how we can use the Docker Swarm in our production lifecycle. So let's just start with. So first, we will go through some problem statements which will be resolved by the Docker Swarm. So team, we have also learned about the containers. We have seen how we can use the containers to run our application in isolation, how the containers are helpful, and how we can execute the multiple containers on a single machine, right? So now the question comes in, why we need Docker Swarm? What is Swarm? When we have already discussed about the containers and containers are resolving a lot of issues, then what is the Swarm? Why we need Swarm? So Swarm is basically used to cluster your Docker containers. So why we need to cluster the Docker containers? So we have a few questions, and these questions will help us to understand the need of Swarm. So this is the first problem statement, how we can scale up the containers. So team, as we know, the things are moving internet very rapidly, and in current time we have a lot of robust and lot of agile applications. So the traffic to any application can divert anytime. Suppose you are owning some e-commerce website, like suppose you are owning Amazon, Flipkart and Snapdeal kind of website, or you are owning the website like Netflix, Amazon Prime, right? And at runtime you are going to launch a new sale, you are going to launch a new web series. So at that particular time you need a lot of resources available in your pool. So the one possibility is you will put a lot of engineers and they will create the container at runtime, right? And they will manage the load. And the another mechanism is you can automate your infrastructure, right? You can scale up your containers dynamically as per the load. So this is the first problem statement where Docker Swarm is going to help us. The second thing is how you can manage your containers, or you can recreate if they fails or crash. So your container is working and suddenly it stopped working, right? It crashes. So how can you manage that particular container? So this is the second statement where Docker Swarm is going to help us. Suppose you are running 4 containers in a production. The first container is active container, second one is the passive container, and 2 other containers are the replication server, right? Somehow your replication server goes down, right? Now replication is not happening between your primary application and your secondary servers. So in that case, how your application will behave? It may possible that your application will crash or your application will stop responding, right? So how we can manage these kind of situations? How we can recreate the containers if they are crashing or they are fails? So this is the second problem where Docker Swarm is going to help us. And the third is how we can upgrade the services with zero downtime. So you are executing a service in a container and these containers are running in the production. So you want to upgrade your container. Suppose you are using Tomcat 801 and you want to upgrade Tomcat from Tomcat 801 to 803, right? But you don't want any downtime. Downtime means your application in the production will not be down for any single second, right? So how you can manage the upgrade of services with zero downtime? This is the third problem statement where Docker Swarm is going to help us. How you can manage the containers, the number of containers on VMs on Docker engine, right? So how the infrastructure is going to identify, okay, that particular node have a lot of containers, and to put more containers on the same node will be problematic. So how we can manage the containers on the VMs and nodes? This is the another problem where Docker Swarm is going to help us. So let's move further and let's see what is the Docker Swarm and how we can use the Docker Swarm, right? So Docker Swarm is clustering and scheduling tool for the Docker containers. With the help of the Docker Swarm, you can orchestrate or you can make the cluster of your Docker containers. With the help of the Docker Swarms, we can schedule the task, we can schedule the services, right? So let's move further and we will see how we can create the cluster of the containers, how we can schedule the task, how we can schedule the services. And the another point is Swarm is Docker's native support, right? It is a native support of the Docker. This is not a third party tool or third party service which we are executing above the Docker. So Swarm is the Docker native support for the orchestration of the clusters and Docker engine, right? When we are talking about the orchestration, what is the orchestration? So orchestration means define nodes and define services. See how many nodes you want to run and where you are done, right? So orchestration means at runtime we will define the number of nodes and the number of services are running on these particular nodes, and we will see that how many number of nodes are basically required at runtime and where these nodes will be deployed. So this is called orchestration. Docker will help us to orchestrate the containers on the Docker nodes. At a high level, we can say that Docker Swarm takes multiple Docker engines running on different host machines and let us use them together. So we can understand this particular thing with a simple example. Suppose we will take an example of the Amazon.com, and Amazon.com has launched, and Amazon recently has launched a new service, Amazon Prime, right? Amazon Prime is operational in multiple countries. In suppose, and many countries have a lot of population, like India have a lot of population, China have a lot of population, US itself have a lot of population. So we need to scale our services as per the requirement. Amazon is going to launch a new web series which is quite popular in India, which is quite popular in America, right? So the people, so the load which we are expecting on that particular servers when we will launch the web series is quite high. So in that case, on the peak load hours, Docker Swarm will help us to manage the Docker engines, manage the Docker containers, and it will decide on which host I need to up new containers and how we can manage them together, right? So at runtime, user is sending the traffic, but on which node that particular traffic will diverse, it is the responsibility of the Docker Swarm. Docker Swarm have two types of node. The first node is called manager or master, and second type of nodes are called worker. Every swarm starts with one manager node, or we can say it's a leader node, right? The algorithm which Swarm is using is called the Raft algorithm, right? So Docker Swarm is highly available, which is just because of the Raft algorithm. Now we will see what is the Raft algorithm. So Raft algorithm has been designed in a particular way that the leader node is constantly checking it with its follower nodes, right? and syncing their state with the follower nodes. So in the raft algorithm, we have one master node and we have n number of follower nodes, right? The master node is checking their state with the follower nodes. In any case, if the master node goes down, then the one of the follower node will create as a master, right? We can understand this particular thing with a simple example. So let's say we have three nodes like A, B, and C, and A is the leader, right? One day in the network transaction, the A goes offline, and B and C are alone, and B and C are not getting any call and not getting any traffic from the A, right? In that case, with the help of the raft algorithm, B and C will elect one of them as a master and one of them as a worker, right? So suppose B is picked as a master, right? Now B is serving as a master, C is serving as a worker, A is offline. After some time, A comes online, right? But when A goes down, it was a master. Now A is master, B is master, C is worker. So what will be the state of A once it will come online? So in that case, A will identify, okay, B is the master in term 2. So A itself downgrade as a worker. Now B node will become a master and A and C will become a worker. So this is called the raft algorithm, where master and worker nodes basically manage themselves, and once the master goes down, any of the worker node will come as a master and serve other node as a worker. Now let's discuss about few benefits of the Docker Swarm. So the first benefit is the task scheduling. So let's discuss how Docker Swarm will help us in the task scheduling. So suppose we have n number of services. So what we need to do, we need to deploy our services as a stack in a swarm, right? So we will create a stack of services in a swarm, and when you declare your services, you provide the swarm with important information about how you actually want your service to be run. This includes the parameter like how many replicas you want on each service, how the replicas should be distributed, when they should only be run on the certain nodes, and more, right? So once the service is deployed, now it's a job of a manager to ensure that the deployment requirement you set continue to met. It means if anyhow the service goes down, a new container will be spinned up. So let's understand this with an example. So let's say you have deployed an Nginx service, specify that there should be three replicas. So it means if anyhow your deployment goes down, it is the responsibility of the manager to spin up the new container with the same configuration, right? The second benefit or the second use of the Docker Swarm is load balancing. So how Docker Swarm will help us in the load balancing? So suppose your service is running and you are running 10 Nginx servers, right? In these 10 Nginx servers, one is the master and rest 9 are the workers. Now it is the responsibility of the Docker Swarm to maintain the traffic on all the Nginx nodes, right? 9 worker and 1 master node. It doesn't mean that the master will not serve the traffic. Master will also serve the traffic, but worker will actually serve the traffic. Master will manage these 9 workers plus serve the traffic. So load balancing is another feature of the Docker Swarm. The next benefit of the Docker Swarm is rolling updates. So if you are running as a DevOps engineer, then many times you have seen that at runtime we are executing 10 servers in a single application, right? And somehow some bugs found in the production, and we need to patch our production. And so in that case, Docker Swarm will help us to patch the running containers. In the Docker Swarm, you can define, okay, two containers at the same time will be goes down, and two new containers at the same time will spin up with the new patch. That means if 10 containers are running on an application, then two containers will be spinned up with the new functionality, with the patch functionality, and 8 are still running with the old. So here you can see there is no downtime. Application is still running. There is user is not impacting, right? User is able to execute their work. It's just the responsibility of the application and load balancer that where it is sending the traffic. In the same way, we can again down the two another containers and upgrade two new containers, down two another containers and upgrade two new containers. So this is called blue green upgrade, and this is called the rolling upgrade or rolling update, right? Where without any downtime we can upgrade the services. This is also the functionality of the Docker Swarm. And last one is the security. So team Docker Swarm comes with the great security features out of the box. When a node joins the swarm, it is uses a token, and that token is encrypted, which is basically decoded by the swarm itself, right? So it comes with a lot of security features as well. So team, this is about the swarm. We have discussed what is the need of the swarm, what is the swarm. In coming lectures, we will see how we can implement the swarm and how we can create the services in the swarm. So thank you team, thanks for your time. Hello team, welcome back. In the previous lecture, we have discussed a bit about the Docker Swarm. Today, we will discuss about the Docker Swarm terminology. We will see what is the meaning of different terms in Docker Swarm, right? So let's start with. So first itself, we will learn about the Docker Swarm. So Docker Swarm is already an inbuilt functionality in the Docker toolkit, which can be used to the cluster management and orchestration of the Docker clusters, right? And the toolkit which is specific to the swarm is called swarmkit, right? A Docker swarm is the combination, or you can say it consists of multiple Docker hosts, right, which run in the swarm mode. When we are talking about the swarm mode, then it means some of the Dockers are running as a manager, which has the manager membership, right, and the delegation, and some of them are running as a workers, right, which we call the swarm services. So the Docker Swarm is basically the cluster management of multiple Docker hosts, or you can say the multiple Docker clusters, where a single cluster is running as a manager mode and rest of the clusters are running as a worker mode. Now first we will see what is the Docker host. When we are saying that Docker Swarm consists of multiple Docker hosts, then what is the meaning of host here, right? So host is a Docker container which can be a manager, which can be a worker, or which can be perform both of the roles, and hosts are used to execute the services. Docker Swarm is also used to maintain, or you can say the schedule the services on the Docker clusters, right? For example, we can say we have the 9 cluster of the Nginx, right? Out of 9, 8 Nginx clusters are running as a worker and a single Nginx is running as a master. So what all the containers are doing, they are executing the service which called nginx, right? And suppose at runtime some of the worker becomes unavailable, right? Then Docker Swarm will schedule that particular worker's task to some other nodes, right? So that it will not impact your traffic, it will not impact your application performance. So Docker Swarm is also used to maintain the service on the cluster, or we can say it is also used to schedule the services on the clusters. So the next thing which we are going to discuss is task, right? In this particular section in the Docker Swarm, you will listen this particular word multiple times. So task is a running container, which is a part of the Docker Swarm service and managed by the Swarm manager, right? So in another word, we can say if a particular container is running a particular task, right? Your particular container is running the Tomcat, right? So Tomcat has a task which will be executed with the help of the container, right? And that task will be managed with the help of the Docker manager, because the task is the part of the service. Now next thing we are going to discuss about the nodes. So a node in the Docker Swarm is an instance of the Docker engine, which is just a participant in the Docker Swarm. So node is used to execute the service, and a single service can have multiple tasks, right? So the plus point with the nodes is that you can execute multiple nodes on a single physical computer or a single cloud machine, right? And suppose you are working in the production, then you can distribute multiple nodes across the multiple physical machines or multiple cloud servers. And next thing we will discuss about the application deployment. So to deploy your application in a Swarm, you submit a service definition to the manager node, right? So suppose you want to start some application in the Swarm, then we need to submit the service definition. The service will execute that particular application, so we need to submit the particular definition of that service to the manager node, and manager node dispatch the unit work called task to the worker nodes, right? So suppose we want to execute an application in a Swarm mode, right? Then first we will define a service which have some parameters. We will submit that particular service to the manager node, and then manager node will define the number of units, or you can say the number of tasks to the workers to execute that particular service. Manager node also performs the orchestration and the cluster management functions, right? Which is required to maintain the desired states of the Swarm. What does it mean, the desired states of the Swarm? It means if some surveys, some nodes are going down in between due to some crash, due to some issues, then Swarm will manage them and it will spin up the new nodes and execute the service on the new nodes, right? Manager node elect the single leader and conduct the orchestration task as well. Now, what is the role of worker? So, worker nodes receive and execute the task which is basically assigned to these workers from a master. And when we are saying a particular service is basically prepared for the application, so service is the definition of a particular task to execute on the manager or the worker node, right? So we need to define the parameters, okay, which task is need to define, and the combination of the input parameter and the task itself is called a service. When we create the services, we also need to specify which container image to use and which command to execute inside that particular container. So suppose you want to execute the nginx and you want to execute the nginx on a port 8090. So nginx, so the execution of the nginx is a task, right? And the combination of the commands as well, this is a service. So as a whole, we are executing the nginx service, and just nginx execution is a task. Now, so as we have already discussed about the task, so task is something which is carried out by the Docker containers and command run inside the containers. Once a task is assigned to a particular node, it cannot move to the another node. This is the thumb rule in the Swarm. If a particular task is assigned to a particular node, that particular task can only run on the assigned node or fail. So earlier we have already discussed that the Docker Swarm can also be useful in the load balancing, right? So Swarm Manager uses the ingress load balancing to expose the service you want to make available to the external, to the Swarm world, right? What does it mean? What is the mean of the ingress load balancing? It means suppose you have an nginx server and there are the 9 or 10 containers which are running in a Swarm mode, right? Out of these 10 containers, 9 containers should be worker and only one container should be master, right? All the traffic which we are putting on that particular nginx server, that will be executed with the help of manager, right? And that manager or master will distribute these commands to the workers. That distribution is called the ingress distribution, right? Master will validate, okay, which node is serving the less traffic and which node is serving the more traffic, and it will distribute the load accordingly, right? So team, these are the words, or these are the things which we are going to use in this particular section, like the task, service, node, host, Swarm, right? So we should be clear about these things, right? So thank you team, thanks for your time. Hello team, welcome back. And today we will see how we can create the services in Docker Swarm. So let's start with. So before creating the services in the Docker Swarm, we will see how we can initialize the Docker Swarm on our machines, right? So let's go to the terminal and verify is Docker Swarm is initialized or we need to initialize it. So right now we are on our terminal, and first we will identify is there any container running. So I will execute a command docker container ls, hit enter. Then you can see no container is running over here. Now, to identify the Docker info, I need to execute a command docker space info. And the docker info command will display all the information about your Docker engine. So you can see we are getting the information right here. We just have the one container which is in the stopped state, right? We have the 6 images. The version which we are using is 18.09.2. Then over here you are getting the Swarm, right? And here is the Swarm entry, and which is showing inactive, right? So what we need to do on our Docker machine, first we need to initialize the Docker Swarm, right? To initialize the Docker Swarm, we have a command docker swarm init. So let me clear out my console. So to initialize the Docker Swarm, we need to execute a command docker swarm init. In some case, this command will execute successfully. In some case, it may fail. So let's execute it. And in our case, the command is failing. The command is failing because we are executing the Docker engine on a cloud machine. And this cloud machine is using two IPs on ETS0, right? They have their own network layer. So we need to specify the advertising address as well, right? If you are getting an error like this, then you need to execute a command if config -a, right? And it will show you the IP of your ETS0, which is 143.209.5.248, right? This is the IP we can use. So we need to execute a command again, docker swarm init hyphen advertise addr, and then provide your IP. Hit enter button. So you can see the Docker Swarm is initialized. In some case, this command, the Docker Swarm init, will work and you will get the output like this. If you are getting the output we have got earlier, right? Then you need to extend the command with this particular keyword and define your IP, right? So right now we can see the Docker Swarm is initialized and it is saying the current node is this. which is a manager. So we have initialized the manager over here on our Docker host machine. And over here we are getting the token as well, right? To add a worker to this swarm, run the following command. So about this we will discuss later on. Right now we will see how we can use the manager and how we can create a service on the Docker manager, right? So if you want to identify that what commands are available with the Docker swarm, then you can execute Docker swarm -help, and it will list out all the commands which is basically available with the Docker swarm. So Docker swarm has few commands available like ca, display and rotate the root ca. We will discuss about it. Init, we have already seen the use of init, which is used to initialize the Docker swarm. Then we have the join and join token. We will discuss about these when we will create the Docker cluster. We have the leave command. This is used to leave the Docker swarm cluster, right? We have the lock and unlock key, right? We will also discuss about these commands. And we have update. We will discuss this command update in the same tutorial, right? So these are the commands which are available with the Docker swarm. Now we are going to create a new service with the Docker swarm, right? So we need to identify which commands are available with the services as well. So I will clear out my console and I will execute a command docker service -help. This will list out all the commands which is available with the Docker service. So we have a command like create. This command can be used to create the Docker service. Then we have the inspect. The same command we have the Docker container as well. This command is being used to inspect the services. Then we have the logs. This command is used to identify the logs of that particular services. We have already seen the use of log command with the Docker container. Then we have the commands like ls to list out the services, and ps. PS is used to list out the task of a services, or you can list out more than one services. We have the RM to remove the services. Then we have the rollback to revert the changes in the service configuration. We will discuss about this. We have the scale command to scale one or multiple services. Then we have the update command, right? To update a particular services. So these are the commands which are available with the Docker service. So we have seen how we can initialize the Docker swarm. We have already discussed about the commands which is available with the Docker swarm. We have already discussed the commands which are available with the Docker service. Now let's see how we can create the Docker service and how we can list out the Docker running services. So let's go to the terminal. Suppose we want to create a service, right? And in that service we want to ping some websites. Suppose I want to ping google.com. So how we can ping the Google? We need to execute the ping, then the URL of the google.com. So you can see by this command we can ping the google.com, right? Now if we want to create a service which will ping the google.com, so what we need to do? So first we need to set up an OS in that particular service, right? So let's see how we can create the service. So I will clear out my console and I will execute a command docker service, and we can use create command to create the service, right? And after this we need to define the image. So suppose I want to use the Alpine image of Linux, and what command I want to execute? I want to execute a command ping www.google.com. What this will do? This will create an service which will install the latest image of the Alpine, right? And execute this command on that particular service with the help of a Alpine. Let's hit enter, and you can see you are getting the status. So over here first we are getting some random ID which is the ID of the service. Then over here we are getting the progress as well, right? So overall progress is 1 out of 1, and verify service conversed, and we are getting the verification status like service conversed, right? Now if we will execute a command docker service ls, this command is used to list out the services. Hit enter. So you can see a service is running. Now this ID is not a container ID. This is the ID of the service which you have created, right? Which you have created on the Docker swarm. And this is the name of service which is Clever Kalam, right? This is the mode which is replicated. Now over here we are getting something which is replicas. What does it mean? So over here we are getting two entries separated by a slash. So the left hand side entry is showing how many replicas is running, and right hand entry showing how many replicas was configured, right? This is the image which is being used with this particular service, right? And this is the port where this service is running. So right now we are not executing any web server or anything else. We are just executing a single command on Alpine, which is ping. So it is not displaying any port, right? So over here we can see this particular service is running. If you want to inspect this service, you can execute a command docker service inspect, and either you can define the service name or you can define the service ID. So I have defined the service name, right? So over here I'm getting the complete JSON which will define the information. So right here you can see the ID is this, the version is this, index 11, created at this particular time, updated at this particular time. The name is this, right? The container specification. So this is the container which is running. So Alpine is the image, latest is the version, and this is the ID of the container which is running this particular service. And the arguments is, what are the arguments? Argument is ping, and what we are pinging www.google.com, right? Initialization false, DNS configuration 0, resources are 0. This is the restart policy, so we don't have, so we have any condition delays this in the milliseconds, and these are the placements, right? So the OS is Linux architecture AMD 64. Over here we are getting the OS information as well, and we are getting some other information as well, like rollback configuration, what is the, and we are getting other information as well, like what is the replicated mode, how many replicas are running, what is the update configuration, what is the rollback configuration, and what are the endpoints, right? So this is the way how you can inspect the services. Let me clear out my console. Now suppose you want to see which container is actually executing your service on a Docker machine, right? So we just started the service, we didn't define the container. For this, first you need to identify the Docker service name. So we can execute a command docker service ls to identify the name. Now you need to execute docker service ps. Either you can define the ID or the name of your service, right? Now you can see it is showing that this is the ID of your container. This is the name of the container, right? Which is clever underscore kalam dot one. This is the image which is executing. The node is this, the state is this, and current state is running since 4 minutes ago. So this container is running your service. If you want, you can specify this as well, like docker container inspect, and define your container ID or name. So this is my container ID, clever column 1, then this is the ID, right? Hit enter. So you can see it is showing the complete information of your container, right? So we just started the service, right? That service started the container where a particular task is running. And what is the task? Task is ping www.google.com. I hope right now you are able to relate the things, right? So with the help of the Docker Swarm, we have started the service. That service started the container, and that container is running a specific task. So we have seen how we can start the Docker services, right? We have already discussed how we can identify the running container for a service, right? Now we will see how we can scale up the services, right? So to scale up the services, we need to execute a command docker service update. Then we need to define the service name. Then we need to define the replicas, how many replicas we want to create, right? So let's go to the terminal again, clear out my console, execute a command docker service ls. So right now you can see we are just executing a single replica. Now suppose I want to update this service and I want to create more replicas. I want to execute 4 replicas of this particular service. So for this we need to execute a command docker service update. Then I need to define the service name, which is clever kalam. Then I need to define hyphen hyphen replica replicas. Then I need to define the number of replicas. Suppose I want to execute 4 replicas of this particular service. Hit enter. Then over here you can see it is showing you the execution order as well, right? So you can see the 4 services has been created. Now if you will execute a command docker service ls, then you can see only single service is running. The name is Clever Kalam, and this particular service is running in the 4 replicas. It means the 4 containers are running which actually executing this particular service. If you will execute a command docker service ps, then define the service name, hit enter, then you can see the 4 containers are running. See, the first container was started 7 minutes ago. Now 3 new containers are started 42 seconds ago. So this is the way how you can scale up the services without impacting the existing running service. How you can scale up the running containers without impacting the existing running container, right? So right here you can see if you want to create more containers which will execute the same service, then with this particular way we can define the more containers, right? So we just need to update the service, and that service, the orchestration system, will automatically create the new services, will automatically create the new replicas of that particular services on another containers, right? Now suppose I'm going to stop some container. So let's clear out the console and again execute the same command docker service ps, then service name. So over here we are getting the containers name. The first container is container clever calam 1, clever calam 2, clever calam 3 and 4. Suppose now I'm going to stop some containers. So docker container rm hyphen f, then I need to define the container name. So suppose I'm going to stop the container 3, right? Hit enter. Now again execute the command docker service ls. So you can see still the 4 services are running. But if I will again execute the docker service ps and then the service name, so you can see right here I will get the 5 containers. See, the clever 3 is basically stopped. See, we are getting the shutdown over here. If I will again execute the command docker container rm and shut down the third container and execute the ls again, then we can see it will stop the container, hit ls. See, only 3 are running out of 4. But if I will again execute the same command, then it will show 4 are running. So it means the orchestration system is basically managing the service configuration. By default, in the configuration there was 4 replicas, but actually at runtime, if any of the container goes down due to any corruption or due to any error, then it will automatically start the new container. It will automatically start the service replica, right? So this is the beauty of the Docker Swarm. This is the way how the production will work, because in the production you can't afford the downtime, right? So you just need to start the service in the production, and docker orchestration system will automatically handle the complete configuration or the complete orchestration of your docker service. So team, this is the first hands-on lecture on the Docker Swarm. In the coming lectures, we will learn more about the Docker Swarm, and we will see how we can create the clusters, how we can auto scale the services, how we can define the blue-green approach, right? How we can rolling upgrade the services and all. So that's all for the day. So thank you team. Thanks for your time. Hello team. Welcome back. In the previous lecture, we have discussed how we can create the Docker services on Docker Swarm. Today, we will see how we can create the Docker Swarm cluster. So in this lecture, we will spin more than one nodes and we will join these nodes in a Docker Swarm. And we will see how Docker Swarm is distributing the services on the Docker nodes. So let's start with. So we are going to create the Docker Swarm cluster. When we are talking about the Docker Swarm cluster, it means we will create the new Docker nodes and we will create the Docker Swarm service on single node which is called master, and then we will attach the other nodes to the master, right? For this we have few options. Either we can do it with the playwithdocker.com, right? So if you will go to the internet, go to your browser and type play with docker, so you will get a link, playwithdocker.com. You need to click this link, right? and over here you are getting the sign in option. So to work with the playwithdocker.com, you need to log in, right? So it will open this particular window, right? If you already have an account on this website, then you can directly log in. Either you can create an account by click on this particular link, right? So playwithdocker.com is a website which will provide you the runtime Docker machines on demand, right? But there is a drawback of this particular website, that the Docker which you will create on this particular website, they will be available only for 4 hours. After 4 hours, the machines or the Docker which you have created on this particular website will be automatically destroyed. So if you just want to practice the Docker Swarm, then you can use this particular website, right? On this particular website, you can create the Docker nodes on demand. In this section, we are not going to use this because we are learning the Docker Swarm from the production point of view. So we will spin up the new machines on the cloud as we spin the deployments in the cloud, and then we will set up the Docker cluster, and then we will set up the Docker Swarm cluster on the cloud machines, right? So this is the first option. Playwithdocker.com is the first option if you just want to hands on the Docker Swarm and you want to create the on demand Docker nodes. And this is a free service, right? So you don't need to pay any single penny for your use. The second option, to create the Docker Swarm cluster on your machine, that you need to create the Docker machine, that you can use the Docker machine plus VirtualBox, right? So you need to download the VirtualBox and you need to create the 3 Docker nodes on the VirtualBox on your local machine, and then you can practice your Docker Swarm cluster, right? The fourth option is, you can use the DigitalOcean. You can create the droplets on the DigitalOcean, which is a cloud machines, right? Then you need to install the Docker on these droplets, and then you can use these droplets to create the Docker Swarm cluster. And the next option is, you can roll out the deployments or the virtual machine on the AWS, Google, Microsoft Azure, and DO, right? So you can spin up your own cloud machine on any cloud where you have the account, and then you can practice the Docker Swarm. So in this particular lecture, we are going to use the DigitalOcean. On the DigitalOcean, we will create the cloud VMs on demand, and then we will install the Docker on these VMs, and then we will see how we can set up the multi-node cluster in Docker, right? For this, first we will go to the DigitalOcean and spin up new cloud machines. So to go to the DigitalOcean, you need to open the DigitalOcean and you need to sign in on your account. So I have already signed in my account. To create the new virtual machines, you need to click on this particular create button and click on the droplets. In the droplets, I need to choose the distribution. So I'm choosing the distribution 18.04.2, 64-bit operating system, the standard starter, and I'm choosing the lower plan, right? I'm choosing the $5 plan, right? I will choose the data center in San Francisco. I don't want any private networking. I don't want IPv6 user data monitoring. I don't need anything. And what I want to spin up 3 droplets, right? So I have plus 3 times and click on the create button. So this will spin up new cloud machines, new 3 cloud machines in few seconds, right? So you can see the processing is being done over here, and as soon as the machine will be ready, they will move in the running state, right? So you can see still it is creating the droplets. It will take another few seconds. Now you can see these 2 machines are being created and the third machine is still in the progress, and all 3 machines are being created. So now you can see our all 3 machines are ready. Now the question is how we can access these machines, right? For this, I need to copy the IP. Suppose I'm going to access the second machine, right? So I will copy the IP, go to the terminal and type ssh root at the rate, then paste my IP. So I want to SSH my machine with the root user, right? It will ask you to enter the password, right? So as we have already discussed in the previous lectures, you will get the droplet password on your email. So if I will open my email, so right here you can see I have the password of my second machine. I will copy this password, go to the droplet and paste it here. Then it will ask you to change the password of root, and it is asking for the current password. So I will again paste my current password, then I will enter my new password, right? Reconfirm my password and you are all set. So right now you can see you are inside the cloud machine. With the same approach, we will reset the password of other 2 nodes, right? So we have reset the password of all 3 nodes. Now what we need to do, we need to install the Docker on these nodes, right? So right now you can see I'm logging on the node 1. If I will type host name, then you can see right now I am logging inside the node 1. Now how we can install the Docker on this machine? So in the same course in lecture 12, we have posted all the commands which is used to install the Docker on your Linux machine, right? So here are the commands. So what I need to do, I need to copy these commands one by one and paste it on my terminal. So I will copy the first command and paste on my terminal. As soon as this will complete, I will paste the second command. So you can see the first is completed. I will copy the second command and paste it as well. Hit enter. Type Y for the confirmation. So you can see right now it is processing and the process is done. Now I will clear out the console, copy the third command and paste it again. So please make sure we are pasting the commands in a sequence. I will attach all these commands with the current tutorial as well so that you guys can get it easily. Now copy the fourth command and paste it. So right now it is installing the Docker on your machine, right? It will take few seconds and done. Now I will copy the fifth command, paste it here. It will take few seconds and it's done. Copy the next command to install Docker CE version and hit enter. It will ask for the confirmation. I will provide yes. And right now it's downloading and installing the Docker on your cloud machine. So it will take few seconds. You have to wait until the complete process will be done. And as soon as this will done, you can execute the command docker version to specify the Docker version installed on your machine. So you can see 18.09.3 is installed on my machine, right? To add the user, I will execute this command sudo usermod -ag docker root to use. Now after this, I want to install the Docker machine as well. So I need to execute these two commands, right? So I will copy this and install it and paste it. So it will install the Docker machine on your node. You can check the Docker machine version with the new command docker machine -version. So you can see the Docker machine version 0.14 is installed on your machine. If you want, you can install the Docker Compose as well. So I will copy this command and paste it here to install the Docker Compose, and it will install the Docker Compose as well. Now I will provide the executable permission to Docker Compose, and if you want to check the version, you can execute this command as well. So by these commands, you can see the Docker Compose version 1.22.0 is installed on this machine. So these commands we need to execute on each droplet we have created, right? So we have set up the node machine 1. In the similar way, we will set up the node machine 2 and node machine 3, right? So now we have set up the Docker on all three nodes, right? So these are the four terminals, right? So this is my main node. If I will type Docker version, so we are working on version 18.09.2. This is the node on which we was working in this particular tutorial, right? And these are the three new nodes which we have spent just before, right? If we will type Docker version on each of these, then we can see here we have the version which is 18.09.3, which is higher release of my current node. And if I will type Docker version, then this may also have 18.09.3. I will type Docker version over here, then this may also have the 18.09.03. See, right? I will clear out the console and I will check if Docker Swarm is already configured or not. So I will type Docker info. So this will provide me the information and it is showing Swarm active, right? If I will type the same here, Docker info, then you can see Swarm should be inactive on this particular node, because by default Swarm is not active on any node, right? If I will type the Docker info on the second node, then this will also inactive over here. See, Swarm is inactive, and same should be the case of the third node. See, the Swarm is inactive. Now what we need to do, we need to initialize the Swarm on all of the nodes, right? To initialize the Swarm, we need to type command docker swarm init, and it is showing some error. As we know, We have seen this error in the last tutorial. I will again initialize it with the extended command docker swarm init hyphen hyphen advertise addr control C control V, then provide the IP, and this is the IP of this particular node, right? And you can see the swarm is initialized, right? We will execute the same command on my other nodes. So right here you can see the swarm is initialized on all three nodes, right? Now if we want to see the commands which we can execute on the docker swarm, then we can execute a command like docker node hyphen hyphen help, right? So these are the commands we can execute with the docker node, like demote, which will demote the node as a manager. Then we have the second command inspect, which we can use to inspect the docker node. Then ls to list out the nodes. Then we have the promote to promote the docker node as a manager. Then we have the ps, right, to identify all the running nodes, to list out the task which is running on the node. Then we have the rm to remove the node from a swarm, and then we have the update, right? So these are the commands we can execute with the docker swarm on nodes. I will clear out the console again on each of my node, and now we will see how we can execute the commands on docker nodes, right? So we have seen what commands are eligible for the docker nodes. Now we will see how we can create the 4 node docker swarm cluster. So right now we have already 4 nodes, right? The 4 cloud machine on which the docker is completely set up. So what we need to do right now, we just need to add these nodes in the docker swarm. And how we can do that? And we can do that with the help of the manager token. So as you remember, when we have initialized the swarm, so it has displayed and joined token, right? So this is the token which has been displayed, right? Now to add the nodes in the docker swarm, we need to find out this particular token for the manager, right? So the node which we want to create the manager, we need to find out that particular token, right? So how we can find out that particular token? You need to execute the command docker swarm join token manager, hit enter. So if we want to promote this particular node, the node 1, as a manager, then we can get that particular token by this command docker swarm join hyphen token manager. So right here what we want to achieve, we want to achieve that my node 1 will be act as a manager and all 3 nodes will act as a worker. So we need to copy this particular token which we have generated, right, and paste it on all the nodes. So as soon as you will execute this command, this will display you an output, this node joined as a swarm as a manager, right? So if I will go to my first node and execute a command docker node ls, right? So this will display you the 2 nodes. See, this is displaying me the 2 nodes, and the manager status is leader and reachable. So which is the leader? Leader is my first node from which I have basically copied that particular token, and this is the second node where I have executed that token, and this is stated as a reachable. Now the same thing we need to execute on the second 2 nodes. So I will copy this again and paste it on my second node. Sometimes you will get this particular message docker swarm, that error from the domain, this node is already part of the swarm. This is the error which is basically introduced on the latest release. Why? Because we have initialized the swarm on this particular node as well. So to exit this particular node from the swarm, you need to execute a command docker swarm leave hyphen f, right? So node left from the swarm, again copy the command and hit enter. So this node will also join the swarm, right? Again execute the same command for the third node, and you will get the same message. Now again if I will execute the docker node ls, then I will see there are 4 nodes. See, this is the leader and all 3 nodes are the reachable, which will work as a worker. And over here we are also getting the version of the docker engine which is installed on my worker nodes and on my master node. So this is the way how you can create the docker swarm cluster, right? So we have initiated the swarm on manager, and then we generated the token and pasted that particular token on the worker nodes. Clear out the console of each of node. Now if I will go to my worker nodes and execute a command docker container ls, so no container is running on my worker nodes. Now what I'm going to do, I'm going to create a service on my master node, on my leader node. So what is the command to create the service? The command is docker service, right? Create. Then I need to define the service image name. Suppose I'm going to create the alpine, and the command what I want to execute is ping www.google.com. This is the same service we have created in a previous lecture. I want to modify a bit. I want to add, let me make it bigger font. Now suppose what we want to do, we need to create the replicas of this particular service as well. So after the create, I will define hyphen hyphen replicas and define the number of replicas we want to create. Suppose we are creating 8 replicas of this particular service. Hit enter button. So it will start 8 services. See, so it will start 8 replicas of this particular service. Once the service will done, you will get the message like this: verify service conversed, right? If you will execute a command docker service ls, then you can see the service is running on the 8 replicas. If you will execute the command docker service ps and define the service name, which is component glued washer, hit enter button. So this will display that which container is running on which machine. So over here you can see the service 1 container is running on machine 3, service 2 container is running on machine 1, another container 3 is running on machine 1, another container is 4 which is running on machine 2, another container 5 which is running on machine 3, another container 6 which is running on machine 1, another container 7 which is running on machine 1 again, and another container 8 which is running on machine 2, right? If we will go to the nodes directly and we will execute a command docker container ls on the nodes, then you can see on my first node 2 containers are running, on my second node docker container ls 2 containers are running, on my third node docker container ls the 2 containers are running. See, so docker swarm has already distributed the service task on different nodes, right? If I will execute the same command on my master node docker container ls, then you can see this is also executing the 2 containers, right? So we have 8 tasks, right? And every task is basically executing in a separate container, right? And docker swarm has already distributed these tasks across the workers and managers. So we have seen how we can create the docker swarm cluster and how docker swarm is basically distributing the task across the master and workers. So this is all for the day. In the coming lectures we will learn few interesting things, right? So thank you, Dame. Thanks for your time. Hello team, welcome back and welcome to the new section of docker swarm. In this particular section we will discuss about the docker swarm basic features and application, right? So first we will start with the docker swarm networks. So today we will discuss about the networks, what networks are basically allowed in the Docker Swarm and how they works. So let's start with. So when we are talking about the Docker Swarm networks, so Docker Swarm works with a completely new network which is called overlay network, right? So overlay is a driver which is used to set up the networking for the Docker Swarms, right? The overlay network driver creates the distributed network among multiple Docker hosts. It means when we are setting up a Docker cluster, then we are basically setting up the multiple Docker host in a Docker swarm. So in that case, overlay network will create a network system which will distribute the network on all the hosts which are connected with the Docker swarm. The overlay network is only used for the container communication, right? The containers which are running on a cluster 1, if they want to communicate with the containers which is running on the cluster 2, then they will use the overlay network, right? The containers which are running on cluster 3, if they want to
communicate with the containers which are running on the master node, right? Then they will communicate with the help of the overlay network. But there's a limitation with the overlay network as well, that overlay network will work on a single swarm, right? If you have a multiple swarms, then you need to define the multiple overlay networks. So we have seen that we have initialized the Docker swarm, we have added the nodes in the Docker swarm. So when we are initializing the Docker swarm, or a Docker host is joining the existing swarm, then two new networks are created on that particular Docker host, right? The first network is the ingress. Ingress is a by default created overlay network with the Docker swarm. When you are basically initializing the Docker swarm, a default overlay network ingress is created on that particular Docker host, which handles the control and data traffic related to the swarm services. So all the services which is running on the single Docker swarm will communicate with the help of the ingress overlay network. Ingress overlay network will work only if you are not attaching the service with the user defined overlay network, right? If you are not defining any user defined overlay network, then definitely the ingress will be the overlay network which will attach to that particular service, and which will be responsible for the complete data flow control on the Docker swarms. As we have discussed, if we are not defining any user defined overlay network, then ingress is the default network which will connect with the Docker swarm service. The second network is called the bridge network. So bridge network is basically called Docker underscore GW bridge. When you are define when you are initializing the swarm, this is the second network which is created by default on your master node or on your leader node, right? Which connects the individual Docker nodes to the swarm node, right? So ingress is basically responsible for the communication of the containers between the Docker swarm, right? And the bridge network is basically responsible for the communication of the node to node, right? How the worker node will communicate with the master node, how the worker node will communicate with the manager node, or all communication which is happening between node to node, the bridge network will responsible for that particular traffic, right? And all the communication which is happening inside the service, inside the containers across the swarm, the ingress or the overlay network will responsible for that particular traffic, right? There are some rules when we are defining the overlay network. The first rule is few ports needs to be empty on the Docker host machine, right? Need the following ports open for the traffic to and from each Docker host participating in the overlay network. TCP port 2377 for the cluster management communication, TCP and UDP port 7946 for the communication among the nodes, and UDP port 4789 for the overlay network traffic. These three ports should be available on the Docker host machine if we are creating the user defined overlay network. The second condition is before creating any overlay network, Docker swarm must be initialized on the node or join an existing swarm, right? So these are the two primary conditions when we are defining the user defined overlay network, right? Now let's see how we can create the user defined overlay network. For this, you need to execute the command docker network create -d, or you can define -- driver overlay. Then you can define your custom network name. So let's go to the terminal, and first let's see is Docker swarm initialized on it or not. So I will execute a command docker info. This is my first node on which we have initialized the Docker swarm. So definitely the Docker swarm should be active on this particular node. And over here you can see the Docker swarm is already activated on this particular node. I will clear out my console, and I need to verify is default overlay network and default bridge network exist on this particular node or not, right? For this I can execute a command docker network ls. It means I want to list out all the networks which is running or available on this particular host machine. So over here you can see, here we have the ingress C, and the driver is overlay and scope is swarm. So if we are not defining any overlay network, any user defined overlay network, the ingress network created by default. And here is the second network docker underscore gw bridge, which is created by default, right? Now let's see how we can create the user defined overlay network. For this we need to enter a command docker network create
-d, define the driver and define the network name, my underscore overlay, right? Hit enter. Oh, there's a mistake. I need to define -d, not -f. Hit enter. You can see a network is being created by this particular ID. If I will execute Docker network ls again, then I can see a new overlay network named my underscore overlay is being created. The scope is swap, right? Now to discuss the use of overlay network, let's create few services on a Docker host machine, right? So suppose first we are creating an database service, then we will create a web service like Drupal, right? And the both of the service will create on the user defined overlay network. Then let's see what is happening inside the Docker swarm. So let's clear out the console, and suppose first I'm going to create the service, the Postgres database service. So Docker swarm Docker service create hyphen name, and I will name it Postgres. Define the network network. Network is my overlay. Define the environment variable password. So Postgres underscore password equals to my password. Then define the image name. So Postgres, right? Hit enter. So this will create the Postgres service. So right now you can see it is preparing the service. Once it will done, it will show you the completion message. So it is verifying the task is stable and service created. If I will execute Docker service ls, then I can see a Postgres service is being created, right? Now suppose we are creating another service, Drupal service, which is a web service and which will use this particular database as a DB. So I will create another service like create like Docker service create name, call it my Drupal network, which will use the same network my overlay. Suppose I'm defining the port, the host port is 80 and access port is also 80, right? And Drupal, hit enter. So Drupal is the image name. So right now you can see it is basically preparing the service. Once it will done, it will show you the confirmation message. So we have to wait until the complete process will done. So right here you can see we are not getting that the image is being downloading and the server is being created. No, just we are getting the service status. If I will execute a command docker service ls, then we can see the my Drupal and Postgres service are running, right? If we will ps these services, so suppose I'm executing the docker service ps, and first I want to identify that where my Postgres is running. So my Postgres is running on my node 3, right, which we have created in the last tutorial, right? And in the similar way, suppose I want to identify where my Drupal is running. So my Drupal is running on port on node 1 c. So they both of the services are running on the separate nodes, right? DB is running on node 3 and Drupal is running on node 1, right? Now let's go to the browser, copy the IP of my first node and paste it over here. Hit enter. Then you can see it is opening your Drupal service. So when you will hit the IP, you will land on this particular web page. Why we don't need to append any port with the IP? Because we have started the traffic on port 80, and by default, if we are not providing any port, then it will take the 80 as a default, right? Now to continue, we need to click the save and continue button. And over here we need to choose the installation profile. So suppose we are going with the standard, and this will land you on this particular web page where we need to set up the database. So as we have already configured and started the service of the Postgres SQL, so I will copy this. In the database name you can enter anything. I'm going to enter Postgres, right?
By default, if you are not providing the Postgres username, then the Postgres user is Postgres itself, right? Then over here, you need to define the password which you have supplied inside your service. So we have supplied the password mypass. So I will define the mypass over here. Click on the advanced options, and here instead of the local host, remove this local host and provide your service name, your database service name. So copy your database service name and provide it over here, right? Click save and continue button. So this will land you on the install site page, right? So right now it is installing the Drupal on your containers. So we have to wait until the complete installation will done. It will take very less time, mostly 20 to 25 seconds. So let's wait. Now you can see it is asking for the site information. So we will provide some information, right? And once you will fill this particular form, click on save and continue. So right now this will land you on the welcome page, right? So let's wait, and we are on the welcome page, right? My site is www.testme.com, right? Here I'm getting the complete configuration. With the help of this configuration, I can manage my site on the Drupal, right? So over here we was accessing one node, right? Let's go to the DigitalOcean and copy any IP. Suppose I'm going to copy the IP of server 3, right? And paste it over here. So you can see this will land you on the same page. Now let's copy another IP. I'm copying the IP of server 2, right? I will paste it here and remove the first one. Then this will open the same page again, right? If I will copy the another IP, suppose I'm going to copy the IP of my node 1, which was the master node, and paste it here, then this will again open the same site, right? So you can see either the Drupal container is running on single node, but I am able to access that service from all the nodes which are running inside the Docker Swarm cluster, right? So what is this? We will discuss these things in the coming tutorial. Today we have seen how we can create the service on the overlay network in Docker Swarm. So thank you, Tim. Thanks for your time. Hello team, welcome back. In the last lecture, we have seen how we can create the multi-node cluster and how we can start up a service on the multi-node cluster, right? And today we are going to discuss how the Docker Swarm manage the traffic, right? So let's start with. So today we are going to discuss about the routing mesh, right? But before moving further, we need to understand what is the routing mesh in Docker Swarm. So team, routing mesh is a mechanism, is an algorithm which is used by the Docker Swarm to manage the global traffic. In the last lecture, if we will go to the terminal, on a terminal, if we will execute a command docker service ls, then we will see we have executed an service Drupal, right? And that Drupal service was accessible on all of my nodes, right? If I will go to the DigitalOcean, if I will copy any of the IP and paste it in a browser, then you can see it will open the Drupal homepage, right? This is the website we have created yesterday, www.testme.com. If I will copy some another IP, suppose I'm going to copy the IP of node 1 and paste it, this will land you on the same page. If I will copy some another IP, right, and paste it here, then this will land you on the same page. So it doesn't matter where the application is running, right? If we will see Docker service ps Drupal, then my Drupal service is running on node 1, right? But still I'm able to access my Drupal service on node 3, node 2, and node 1 itself. So this is called global traffic management. And how Docker Swarm is managing the global traffic management? The Docker Swarm is managing the global traffic management with a mechanism or algorithm which is called routing mesh. So we will discuss what is the routing mesh and how Docker is managing the global traffic inside the Docker Swarm. So what Docker Swarm does? Docker Swarm publish the services on some ports, right? And allow the outer worlds to access these services. So in the last lecture, when we have started the Drupal services, we have exposed that services on port 80, right?
and we are able to access the service with the help of the IP on port 80. This is called ingress routing mesh, right? So whenever you are creating the service and you want to access that service on the outer world, then you need to publish that service on some port which will be accessible from the outer world, and this all mechanism is called the ingress routing mesh. What ingress routing mesh does: so the ingress routing mesh enables each node in the swarm to accept the connection, right? It doesn't matter that my service is running on node 1 or node n or node m or node k or node n, right? It doesn't matter. Routing mesh enables each node which is connected in the swarm to accept the connection on the published port, right? If we have published our service on port 8080 or port 9090 or port 80, so if you have published your service on any port, if you are accessing that service, right, in that case the routing mesh is responsible to enable each node in the Docker swarm to accept the connection on that published port for the specific service, right? And routing mesh routes all the incoming requests from the outer world to the Docker swarm to the published port on available nodes to an active container. And how routing mesh is doing all these things? Routing mesh is doing all these things with the help of Docker Swarm Load Balancer, right? So we will discuss all these things with the help of a picture as well. Right now, what we are doing, we are starting in service on a port which is accessible from the outer world, and Docker Swarm making that service available on that port on every node, right? With the help of the routing mesh algorithm or routing mesh mechanism. And how routing mesh mechanism is managing all these things? It is managing all these things with the help of the Docker Swarm load balancer, right? So this is the command we have executed yesterday. We have executed Docker service create, then we provide the name Drupal, then provide the network overlay network hyphen p 80 colon 80, then the service name. In this particular command, we have basically published the service hyphen p, then 80. The left hand side port is the published port, right? And the right hand side port of the colon is the container port. So 80 is the published port which is published with that particular service to access that service on the outer world, right? And the internal port is also 80. It means the right hand side port 80 will manage the traffic inside the container, but the left hand side port 80 will accept the traffic from the outer world, right? So the published port is a port where the swarm makes the service available, and the container port is the port where container will listen the traffic. And we have already discussed that routing mesh listen on the published port for any IP address assigned to a particular node in the Docker swarm. Now let's discuss this. How routing mesh listen the published port on any IP address which is basically available in the Docker swarm. So suppose this is the diagram of my service. Right now I have executed my service on two replicas. It means two container which I have displayed in the yellow color are running the service, right? First container is running the service on port 10.0.0.1 port 80, and my service name is myweb1, right? The second is running on port 10.0.0.2 and port 80, right? So the first one is the node 1 and the second one is the node 2. Node 3 is still not running any container which executing my service. So it means in my Docker swarm, I have three nodes. Out of these three nodes, two nodes are running my service and each node is running a particular container for my service, right? Now, if I will access my service on any of these three nodes, right, that particular request will directly land on the Docker Swarm load balancer, and then Docker Swarm load balancer will identify the container where it will route your traffic, right? Why we are calling it load balancer? Because this is balancing the load. Somehow if node 1 is not able to process your traffic, then it will calculate it itself and route your traffic to the node 2, right? So I hope with this particular picture you are able to get the point how the routing mesh algorithm is working, right? It doesn't matter on which node your container is running, right? If you will access any node which is available inside the Docker swarm on the published port, then you would be able to access your services, right? This is the beauty of the Docker swarm. You don't need to specify any particular container. You don't need to specify any particular node. You can access your service on any node which is the part of the Docker Swarm. It doesn't matter that that particular node is running your service or not. This is called ingress network or the ingress routing mesh. If you want to verify that where your service is running, then you need to execute this particular command, docker service inspect hyphen hyphen format. We are formatting the endpoint specification port. Then I need to define the service name, right? So let's execute this particular command. So I have typed the complete command, docker service inspect, then in this particular format, and my service name, right, which is Drupal. Hit enter button and you will get the output like this. See, this is the protocol TCP on which the particular traffic is routing from the outer world. Target port is 80, published port is 80, and published mode is ingress, right? You can see over here. So this is the way. If you want to identify that on which port my service is exposed, on which port my service is available for the outer world, then you can execute this particular command to identify the port where your service is running for the outer world and where your service is running for the container itself. So this is the answer of the question which we have raised in the last lecture. We was able to access our service on each of the node which are part of the Docker Swarm, although my Drupal service is running on single node in this particular swarm, right? So the routing mesh algorithm or routing mesh mechanism is responsible for these kind of flexibility, right? If your service is running on any of node, you don't need to worry about anything. You just need to hit a particular DNS or you want to hit a particular IP to access your services, right? So this is all for the day. Thank you, team. Thanks for your time. If you have any question, any doubt regarding this particular lecture, then please let me know and I will happy to answer. Thank you, team. Thanks for your time. Hello, team. Welcome back. In the previous lectures, we have seen how we can create the network in Docker Swarm, how we can create the services, how we can create the nodes and attach the node to the Docker Swarm leader, right? Today, we are going to post an assignment, and in this assignment, we will deploy a multi node service. So, I'm going to mention all the possible details which will help you to complete this particular assignment, right? And I hope you will complete it before jump to the next lecture. So, let's start with. So, team, in this particular assignment, we are going to deploy a multi-node service with the help of Docker Swarm, right? So there's a very famous distributed voting app, which is called Docker's distributed voting app. This app is basically published 2 years back in 2017 with the Docker community. And this is the architecture of this particular app. This has the 5 services: the front end service, voting app, which is written in Python. Then we have the backend service, result app, which is written in Node.js. The front end voting service, which is written in Python, will store the data in key value pair in the Redis, and that Redis will directly communicate to the worker, which is written in .NET, right? That worker will read the data from the Redis, and then it will write that particular data in DB, which is the PostgreSQL DB, and result app will read the data from the PostgreSQL and display to the user. So there are the 5 components of this particular app, which is a distributed. You can see the all the containers are basically independent from each other, right? If any service will goes down, it will not impact the complete application. So we are going to implement this particular multi-node service with the help of the Docker Swarm in this particular lecture. So this is the assignment for you. You need to implement this particular multi-node service with the help of the Docker Swarm, right? So I'm going to provide some hint that how you can deploy it, right? And I hope you will complete this tutorial by yourself. So we have the 5 services in this app, and these are: the first service is vote. This is an front-end service, enables the user to choose between cat and dog. You will display 2 options, the cat and dog, and you have to vote for these, right? The second service is Redis, which is the database for the front end service, and it will store the key value pair, your vote and vote option. Then the third service is Worker, right? This service will read the votes from the Redis, the key value pairs, process these, and publish these to the PostgreSQL database, right? So the next service is the PostgreSDB, which will store the votes in the database. And the last service is result, which is again front end service which will display the results you have voted. So these are the 5 services which will be work as a combination, or you can say as a composite application in the Docker Swarm. So we are going to deploy these and we are going to connect these with the Docker Swarm. So here are the hints which you can use. So this is the service which is the combination of several Docker and Docker Compose file. If you want to review the code, then here is the location. You need to click this to open the code, and you can see this is the repository of Docker samples, which is the official Docker samples repository, which is the official Docker community repository, right? And you can see here we have a lot of Docker Compose and Docker YAMLs, right? So this service is the combination of multiple Docker files. This app is designed by the Docker community and which is available for the public to use. So we can directly get these images from the hub.docker.com. This is the minimum requirement for this service. This service needs one mount point volume, two networks, and 5 stack services, right? So the mount point volume will be used in the DB. The network will be used as a backend network and the front end network. And these are the 5 services. So we need 5 stack services. So first we will create the two overlay network. We can call it front end NTW and backend NTW. It means front end network, backend network. Then first you will deploy the voting app, and you can download the image from this particular location. Docker samples slash example voting app underscore vote. And we need to download the image which is tagged as a before. So if we will go to the hub.docker.com, so we are on the hub.docker.com, and if we will go for the search, and over here if we will type Docker samples, so you can see you are getting a lot of images on the Docker samples. So here's the Docker samples. If I will click this, then I will get the complete information. So this is the community organization which is owned by the Docker, right? The website is docs.docker.com. So this is the official repository of the Docker samples project. From this we can download our images, right? So the first image is Docker sample voting app underscore vote. So this is my first image which I need to download. And if I will go to the tags, then this is the tag, the before tag I need to download, right? You can see this image already have 1 million plus downloads, right? This is the front end app, and we need to publish it on port 5000, and container will listen on port 80. We need to publish 5 plus replicas of this particular service, and we need to use the front end network as a overlay network for this particular service, right? The next service which we will spin is the Redis. We need to use the Redis 3.2 image because this is the compatible image with this particular app. Redis will be used to store the key value pair data for the vote and vote option. We need to publish again the 5 plus replicas or 2 plus replicas for the Redis. We don't need any port or we don't need any network to provide to this particular Redis service. The next image you need to download is the worker image, right? And for this you again need to go to the Docker samples example voting app underscore worker and tag latest. So we need to download the example voting app worker latest image. If we will again go to the hub.docker.com, right, and we will search for the worker app underscore worker, see this is the option. So we need to download this particular image, and this again have the 1 million plus downloads, right? If we will go to tags, then we can download the latest tag, right, which is 497 megabyte in size. This worker app will process the Redis stored data in the Postgres, and we need to publish only one replica of this particular worker app. The next app we need to spin is the DB service. The image which we will use is the Postgres 9.4. We need to mount the volume, and so that we will create a external mount point, and we will point that mount point to the where lib PostgreSQL data. Why we are pointing this mount point to this particular location, I will explain it shortly. And we need to publish the DB service on network backend network. publish only one replica of this particular service. So till now we have created 4 services. Now let's move to the last and next service. And next service is result service, which is again an web app, and we can download the image from the Docker samples example voting app underscore result and again tag the before image. This image will display the voting results, and we need to publish this image on the backend overlay network. Publish this image on port 5001 and container port 80. Publish one plus replica of this particular service. So this is the assignment. I hope I have already provided a lot of hints how you can create and deploy these services. So I hope you will create and deploy the complete service by your own. If you are still not able to deploy it, in the next lecture I am going to publish the solution. So move to the next lecture. Thank you, team. Thanks for your time. Hello team, welcome back. In the last lecture, we have posted an assignment for you. I hope all of you have already resolved that. If you are not, then we are going to post the answer in this particular lecture. So in this lecture, we will solve the assignment which we have posted in earlier lecture. So let's start with. So the assignment was to deploy a multi-node Docker distributed voting app. And this was the architecture of that particular app, right? So what are the part of these services? So here we need to implement 5 services: the vote, Redis, worker, DB, and result, right? I have already posted some hints to deploy the same. So as I mentioned, it needs one mount point. We have already discussed in the Docker that how we can create the mount points. We need 2 networks and 5 services, right? So first we will create the networks. To create the networks, you need to execute the command docker network create -d overlay, then your network name. So we will go to the terminal and create the network. So we are on terminal. First, we will identify how many nodes are connected in my swarm. So you can see 4 nodes are currently connected with my swarm. One is down, right? Now we will identify how many networks are running. So you can see these are the networks which are running on your machine. So there is one ingress network and 2 overlay network. See, this is the my overlay which I have created earlier. Now we are going to create 2 new networks. So create network. So we will execute a command docker network create -d overlay, then network name. First I'm going to create the front end network. Oh, there's a typo mistake in the create command. It's CREATE, not RE. Hit enter. So you can see network is created. I will clear out the console. In the similar way, I will create the backend network. So I just replace the front with the back in the earlier command. So the command is docker network create -d overlay back underscore end underscore ntw. So you can see backend is already created. I will execute a command docker network ls. Then right now I have the front end and backend overlay network. Right, you can see the driver is overlay and the scope is swarm. Again here the driver is overlay and the scope is swarm. Right, now we will see what applications we need to deploy and how we can deploy them. So first we need to deploy the voting app, the Python front end app. This is the image which we want to use. This is the web front app which will publish on port 5000 and container port 80. Publish 5 plus replicas. So over here I have mentioned the complete command, right? Docker service create -name. I will name my service vote. Then put the port on which you want to publish -p 5000 colon 80. Then on network -network I want to publish this app on front end network. Then -replicas I want to create 5 replicas, then the image name, right? So I am going to copy and paste the same command on a console. Docker service create -name. I will name my service vote -p 5000 port 80 -network. I will define front end network. Then I need to define the replicas. Here we are going to create the 5 replicas. Then I need to define the image name. The image name is docker sample slash example voting app underscore vote hyphen before. Hit enter. So this will take few seconds to download the image and create the 5 replicas of this particular service. So we have to wait until it will complete. So you can see the 3 out of 5 is done, 5 out of 5 is done. It is verifying the stable state of the service and it's done. If you will enter docker service ps, then define your service name, which is vote, then you can see the 5 replicas of this service is running, right? Some are running on node 1, some are running on node 3, and some are running on node 2. Clear out the console and move to the slide back. The next service which we want to create is the redis. So we'll take the image redis 3.2, and this is the purpose of the redis. We will create the 5 plus replicas of the redis, and command is simple. We need to create docker service create hyphen hyphen name. I am going to keep the name redis. This will use the front end network and 5 replicas and redis image. Let's go to the console. Docker service create hyphen hyphen name. I'm going to keep the name redis hyphen hyphen network name is front end underscore ntw hyphen hyphen replicas. I'm going to create the 5 replicas, then the redis 3.2. This is my image and image version. Hit enter. Again, it will take few seconds to create the service. So you can see it is processing, and you will get the overall progress as well. And shortly, 5 tasks of this particular services has been created. If you will enter docker service ps redis, then you can see the 5 containers are running on different host machines, right? Some are running on host 1, some are running on host 2, some are running on host 3. Clear out the console, and let's move to the next slide so that we can create the third service. And third service is the worker service. The image we want to take is docker examples example voting app underscore worker latest. This will process the redis data and process this data into the postgresdb. This will use the front end and back end network. The front end, over the front end network, it will receive the data from the redis, and with the help of back end network, it will supply the data to the postgres. And we need to use just one replica of this particular service, right? So this is the command docker service create hyphen hyphen name. I will name my service worker hyphen hyphen network front end hyphen hyphen network backend. I need to mention both of the networks. Then the image name. Why I'm not defining the replicas? Because there's only one replica required, so we need to define the number of replicas. So let's go to the terminal and execute this command. Docker service create hyphen hyphen name. I will name it worker hyphen hyphen network. Define the front end network hyphen hyphen network again. Define the back end network. Then we need to define the image name. Docker sample slash example voting app underscore worker latest is my image name. Hit enter. This will download the image and execute your service. So you can see it is in progress. I think this particular image is 425 megabyte in size. So this will take few seconds to download and configure your image. Now, if you will verify the service, Docker service ps worker, then we will get the result like this. So you can see over here, the 4 services are failed in a row, right? But still one service is running. I can explain it, right? So the reason is we have executed 5 redis on the front end network, right? And this particular service is using some kind of socket programming, and socket programming is not still implemented in a proxy way in this particular service. So in that way, it just compatible with single redis. It is not compatible with the replicas of the redis, right? So it is connected on the redis where the dns was available. If you will go to the logs of this particular service, docker service logs, and define your service name, then you will get the socket exceptions. See, these are the errors, and what it is saying: system aggregate exception, one or more error occurred, no device or addresses. And you can see there are some kind of socket exceptions: socket exception factory, no such device or addresses. So actually it is not able to find out the DNS address in the Redis, so that it is failing on the front end network, right? Only single Redis is compatible with this particular service, so that it got success on a single Redis, right? Clear out your console. Now let's move to the slide and create the another service. The next service is DB, right? So we need to take the image Postgres 9.4. We need to create the mount volume and mount it to the where lib PostgreSQL data. This is the hard code value in the image. Let me explain this. So this is the git code location which I have mentioned in my assignment, and if we will go to the docker YAML file, see docker compose YAML file, if we will open this, then if we will scroll a bit, then you can see it has mounted the db volume db-data to this particular location where live PostgreSQL data. So we also need to create the mount point in the same format, right? The mount point volume name would be, the source will be db-data, and this should be the target where live PostgreSQL data. We have already discussed how we can create the mount points, right? And you can see this is using Postgres 9.4 and the container name is db, and this should be published on the backend port, and only one replica is required. So this is the command which you can insert to create this particular service. Docker service create, I will define your service name, I will define db, then define your network, I will define the backend network, hyphen mount, the type is volume, source is db hyphen data, we have seen in the docker YAML file, and the target is where live PostgreSQL data. This is already mentioned in the target file, this is already mentioned in the YAML file and the Postgres 9.4, right? So let's go to the terminal and execute this command. So docker service create hyphen name db hyphen network backend network, right? Define the mount point, type equals to volume, source equals to, what was the source? db hyphen data. And what was the target? Target was where lib PostgreSQL data. This was the target mentioned in the YAML file, and we need to define the Postgres 9.4 and hit enter button. Oh, the command is getting failed. Invalid argument volume for mount flag invalid field. Space must be key value pair. Oh, maybe there is some kind of space error. Let me figure out. So we have the volume. So we have the mount point type volume, not the bind. I will remove the space between these commas. Source equal to this and target equals to this. Hit enter and see it is working. So there was some space between the comma and the source db, right? So we need to take care these kind of stuff when we are working with the docker and docker containers, right? So you can see the service is ready and it will be stable in very few seconds, and service is created. If we will execute docker service ls ps db my service name, then you can see the service is running on container on node 1, right? Now let's move to the slide and execute our last service. So this is the last service we need to execute, which is result. The image what we want to use is the docker sample slash example voting app result. Before it will display the voting result and should be published on the backend network. They should be published on port 5001 and container port 80, and we need to publish only one replica. So this is the command we can use: docker service create name result network backend port 500180 and the image name, right? So let's go to the terminal and execute our last service. So docker service create hyphen name, I will name my service result hyphen network, I will define the backend network hyphen p port 5001 colon port 80, then my image name, paste it over here, hit enter button. So you can see service is basically in progress. So you will get the success message when the service will be created, right? So we have to wait until the service will be created, and you can see it has been downloaded and it has been stable in next second. So docker service ps result, and you can see my service is running. If I will execute a command docker service ls, then you can see all of my 5 services are running: the db, redis, result, vote, and worker. 5 replicas of redis is running, 5 of vote is running, rest all the service are running on single replica, right? My front end service is accessible on port 5000. My backend service is accessible, my result service is accessible on 5001. Now we will go to the DigitalOcean, copy the any IP. Suppose I'm going to copy the IP of node 3, go to the browser, paste it here, and access on port 500, right? And you can see you are able to access the service, right? And over here we are also getting that this service is basically processed by which container. This is being processed by container which have the id F5E58265A3 If I will refresh it, you may get the different container. See, the container is divided. This is called the load balancing, right? Docker is internally balancing the load. We have already discussed it. If I will refresh it, it may be changed or maybe go to the same container, right? Every time you will refresh it, you are getting the different container id, right? So basically 5 containers are running for this particular service, so that we are getting the different containers id, right? Now if I will vote for the cat, right, so you need to click this. You can see a right sign is being over here. Now I will again go to the DigitalOcean, copy any IP which is the part of my docker node, paste it here, and access on port 5001, which is the result app, right? And you can see the result over here. See, cats are getting 100%, dogs are getting 0%. If I will go to the DigitalOcean and copy any other IP, suppose I'm going to copy the IP of node 2, again access it on port 5000, so it will ask you to vote again. I will vote for the dog, right? I will again go to the result and refresh this. So you can see the cats are getting 50% and dogs are getting another 50%. So this is the way how you can create the multi-node service distribution with the Docker Swarm. And as we have already discussed, all these services will be accessible on each node, which is the part of the Docker Swarm, right? So this is the solution for the assignment which we have posted in the earlier lecture, right? If you have any doubt, then you can ask your doubts, right? I'm happy to answer. So thank you, Dean. Thanks for your time.